Hello, hello. Boom, 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 boom. We are continuing the rewrite of the self-hosted cast. Today, hopefully, I will finish the parser. Or, I mean, like, make it be able to parse the same way as the current parser does, and maybe we could think of some improvements. Alright, so right now we can parse the hello world. Right? This is the output of the parser. No, we have a mismatch. Forget about it. Right. So the reason it's mismatch is because I need to go to the Kast syntax, and when I am applying a function like this, is because the groups are not supported. So if I remove this thing, then it's going to parse. There we go. So that's the result. We have the application of the function apparent with the argument hello world, and it is all inside of a statement because we have a semicolon here. All right. So let's start by making the groups work. The groups, they already work in terms of like creating the state machine, but I need to collect the parsed thing into the structured structure, right? Right. So when we have AST, we have children in every group. And the children can contain inner groups, so we have the top level group and then some child ones, right? But when I'm in the parser trying to collect the values, so we have the parsed parts, which is just a list, a flat list of the parts, and the rule parts, we are assuming that this is also flat, but this is actually nested structure, right? The parsed parts are also going to be flat, always going to be flat here, while we are traversing the state machine. And like this is the thing, the function that is converting from the flat list of parts to the actual like group, right? Yes. So the way that we do it here is if we have if in the rule part we are expecting to have a group, so it doesn't matter what is the actual thing, but if we have a group, so this is the rule group, right? In this case, we need to do something. This group has name, it has parts, it has quantifier, it has wrap mode. So technically, we should add the thing, right? Let's do this. Let name be equal to rule group name is an optional string. Then we also have parts quantifier wrap mode. So wrap mode is something that we can ignore. You know what? Let's just list all of the things here. That probably makes sense, right? So we have name, parts. So this is the rule group parts, quantifier, and wrap mode. Wrap mode is only used for formatting, so it doesn't matter. We can ignore this thing. Oh, Spike. So we need to construct a value of type group and then edit. Right, so we're supposed to have something like this. Group. So what is the group is the only question. We need to parse these parts. But the quantifier is like whether the group is optional or not. So do we actually match this group or do we skip it is the question. And that is something that I don't preserve when I'm traversing the state machine. Can I somehow like have this information present? Can I somehow have this information present? I don't think so. So because of that, the way I was doing it before is we match the group based on like the first token, basically. And it also means that for the optional group, the first part was required to be a keyword. So we know immediately if the group needs to be collected or not for optional groups. Right? So yeah, so we potentially want to skip this one if and since I want to skip this one but I don't want to skip that one, it means that we don't do this a loop either, right? I want to say that we have the rule part index and then we also have the part index 0. And we do something similarly to this here. We say while part index is less than parts length, parsed parts. Should I call this then parsed part index? And we say that parsed part is parsed parts at parsed part index. The referenced also probably, right? Wait, this is not. So I need to do this also. Let's do that instead. So yes, over here we say parsed part index plus equal 1 and rule part index plus 1 because we have matched both of them, right? Right. In this case, though, if the group is optional, let's do this. If rule if quantifier, I guess we can match quantifier, right? So if this is the not optional group, then we will always match it. If it is an optional, then we need to do something. So if it's an optional group, we just need to check the first part, the first non-white space part, I suppose. In the rule group parts. Rule group parts. Iterate. And then we want to find. Iterate find. I want this to be in the standard library probably. The part which is not white space. I kind of want to have like a syntax for the like. I mean, ideally we just write something like not part is white space, right? But we don't have this as a boolean operator. But let's try to have the syntax for is value is pattern, and then we implement syntax value is pattern as match value with if it matches the pattern, then we return true. Otherwise, we return false, right? Like simple as this is what we want. It's not 70 though, the priority. Let's take a look at the priorities real quick. Something like as is probably the same priority, 60.5. Let's do that. I'm wondering if this will work or not. It says expected end of file got a colon because this colon is not expected after is. Let's see. Colon is the variant, right? Yeah. No. We want this to be lower priority actually. But maybe it's like 41. Yeah, I think it's like 41, like right under the variance. 41. Now it's parsed. Okay, nice. So I want to also have the thing called iterFind. This is going to be the thing which has the iterable of keys and returns predicate, which is the t into boolean, and it should return an optional t. Let result. We just do with return here, and then we do for value in iterable. If predicate value, then return some value, otherwise return none. All right, and then we want to have the group, right? So this is the first non-white space part. It's an optional syntax rule part. This should be like dereferenced here though, right? All right. You're running Windows 11 IoT Enterprise for ARM64 on a Lenovo IdeaPad Silk Qualcomm. Nice. Windows Pog? Or no? Wait, I'm confused. Why are you using Windows and not Linux? Why is it not NixOS there? Okay. Let's also have the expected keyword is match first non-white space part. Right? Because if this is some keyword, then it is keyword. Otherwise, if it's none or not a keyword, then we are actually going to panic, because like that's what we expect to have from the optional groups, right? Panic. Optional group is supposed to have a keyword as first part. I guess we do like some reference to the keyword, right? Because that's what we are doing here. Dun, 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 dun. So then we say that if dun, 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 dun. Keyword incorrectly matched, right? So what I want to say here is so we have the parsed part. If it's a keyword matching the expected keyword, then it's fine. Otherwise, we don't do that, right? So So should match group is should match group is match parsed part with if it's a keyword token, then token shape is equal to the expected keyword. Then we are going to match the group. Otherwise, we are just going to say false. We should not match the group. That's all. Right? And so then we say that if we should not match the group, then I'm just going to continue, right? But I'm going to skip the rule part index. So we're going to skip the optional group here. Otherwise, we are always parsing this group, which means that I should collect values recursively here. The issue is, though, that we are collecting them from the same parsed parts. So when we're collecting the values, this should be done from like the parsed part index, right? Is what? I need to have the mutable reference to, because I don't have like the slices yet of the arrays, the views into the array. And well, I need to mutate it anyway, right? Because like then this should return how many things I have actually parsed, right? Right. So we have this mutable, and so we don't have this thing. We just dereference. Dereference plus equal 1. So this over here returns the group, right? So what I want to say is that I want to collect values from the parsed part index, parsed parts, and now the parts of the rule is going to be the rule group parts, and this should give me the group as the result. Which also means that I guess this is going to be a reference to. Okay, what is the mismatch here now? Mutable reference, and reference is not array list and reference to array list. There is one thing missing. Collect values. But wait, but this has 3. Oh, it's because over here I'm collecting the values with the 2 arguments. So this is the actual, yeah, the error is over here. Right. Makes sense. So we start with mutable reference to 0 here. Right. Well, actually, right, I need to like make, yes, and to make sure that over here we're skipping the white space in the end. This should be done then. Well, this is skip rule white space, right? This should make sure that there's nothing left in the rule. But how do I make sure that there is nothing left in the parsed parts? Right? So I just should say something like, you know what? You know what? We should just collect the values without this index. But this is over here going to be collect values from, you know, and this should be like collect values from. So collecting the values takes the rule parts without the index, returns the group. This is going to say that parsed part index is 0, and then result is collect values from parsed part index. Also, we're kind of like collecting the rule here itself, so let's just give it the rule. There's going to be rule parts. And the return result. So I just give you the rule. So we just want to make sure that all of the parsed parts were collected, right? So if parsed part index as less than parsed parts length, then I just return the result. Otherwise, I'm going to panic. Too many values supplied for the rule. Also over here we can see like write print parsed parts. How about this? Print parsed parts. Alright, so here before panicking, I'm just going to say print parsed part. So, parsed parts. Rule part. Rule group. Data not data does not match. What do you mean does not match? What do you mean does not match? Syntax rule part is not whitespace or keyword. Yes, but that's like over here. collect values from. This takes the indexed, parsed parts is a list of parsed rule group parts. Rule group parts should be done by reference. Yes. So this is the. Wait a second. Yes, this is array list of parts. It's a reference to, yes, array list of those things, yes. What's the issue here? Syntax rule part is not that. Wait. But isn't this exactly what it is? Syntax rule part is white space or a keyword. Oh, I know. It's because over here, white space, this over here requires the data associated with it. Otherwise, it doesn't check. Yeah, the error is pointing in the a little bit wrong direction. Okay. Too many values supplied for the rules, right? So I have collected print hello world and closing bracket, but it says too many values supplied for the rule. I should also say what is the rule, right? What's the rule? Rule is escape string rule name. How about that? Right, so I'm parsing the rule core apply, which is correct, of course. But why? Wait, yes, it's the other way around. If it's less than, then it's too many. Otherwise, we return result. This if is flipped. All right, so now I have parsed the hello world. Let's also parse the other file, some random file like source token, and see what's going to happen. I think we might have an infinite loop here. Let's say over here, log debug log info collecting values for rule for rule name. Let's do info because the other logs are suppressed. Hello, Ben chilling. Right. So yeah, I have parsed a bunch of things. And then I'm collecting the values. Let's just say over here, values have been collected, just so that we understand that the infinite loop happens inside of the collect values. Yes. All right, so why is that? It's because sometimes something can happen. Like in this loop, do we ever continue? We do continue. Oh, wait, what is this? Rule part index, semicolon, continue. This is supposed to say plus equal 1. That makes sense. It's the optional group. there. Okay. And now we say unreachable. Now we say unreachable. Which one is unreachable? The comment? It's probably the comment. Let's also say that when I have collected the values... No. Like over here when I made progress, I want to say what have I parsed, right? Log info parsed at... I need like the different login API though. I have span print. Okay. Do I do the different logging API? I think I do. Let's rename this to trace message. Let's rename this to debug message. Rename this to info message. Rename this to word message. Rename this to error message. Having fun with those emotes, Ben Chilling? Let's call this with level message. And then I will have the regular with message. So the regular with message is going to be a function that like uses the output functions, I suppose. So instead of like writing the message here, we're just going to say message like that. And then with level message is level and message string. This will just do with level current output write message like that. Right. So then I will have the similarly just regular functions. He was doing an experiment to see if you would troubleshoot the chat if it was in emote only. I mean, if the chat was in emote only mode, I would see it. It tells it. The mode of the chat. Wait, what is this? Mad info message progress? I think my rename actually did not do it correctly. It seems. Wait, but where? Mad info? Over here. Okay. Yeah, I think my renaming. It seems like the renaming was not doing it correctly. Not mutable. Not. That's correct. Number literal is deferred as mutable reference over here. No, it's not. Wait, copy values. Nope, nope, nope. Why is it inferred like that? Hello, bad cop. Why does it say that number literal inferred as mutable reference? It's not as mutable reference, just as reference, which means that I'm referencing it somewhere. What is this language? This is my own programming language. I'm doing the self-hosting, which is rewriting the language in itself. I'm working on the parser. Hello. Where'd my hair go? I just like used a brush.
Are you using LLVM backend?
No, I'm not using the LLVM backend. I'm using the JavaScript backend. Thanks for the bits. Appreciate it. LLVM is going to be in the future. Right now I'm using the JavaScript. Then once the self-hosting is done, I'm going to work on the C transpiler instead. Then the LLVM. This is not a web-only language, no. But the web is the important target for me. And also JavaScript is just easier to write the as a compilation target, right? Because it's a higher level language, so there is less work needed to be done compared to using LLVM or C. Where is drink water? I have tea. All right. Yeah. Let's figure out why is this inferred to be something wrong. If I remove this.
Drink JavaScript.
Drink JavaScript. Oh, I see. It's because, yeah, over here, see, I'm dereferencing it. So since I'm dereferencing this here, it is inferred to be a reference. But yes, in this case, I don't need to do that. Correct. Yes, all the errors are gone. And we are still at unreachable. Yes, so this unreachable is because of the comments. Because I have parsed...
Drink Java.
I wanted to say what I have parsed, right? Parsed at... This is going to be drink... No, not drink. Info. And over here we say... current output write parsed at, and then we say span print the camera is wild. Yeah, it's because like
Java shit.
Yeah, it's because the sun is like moving, like shining there. I have like this piece of cloth here, but it's like it's going to be gone in a couple minutes. It's fine. Java shit. JavaScript is a good language as a compilation target. You will not be able to prove me otherwise. It is a horrible language to use for humans, but for using it as the compiler output, it's amazing. Okay? Use Python as intermediate representation. Python is okay, but Python doesn't work on the web. I guess Python would also work, though. JavaScript. Just works, though, on the web, but without, like, doing things. Alright, so I parsed this one, right? There we go. I parsed this, and as you can see, the next thing is we have some comments here. And because I have the comments, it does not work. Let's see, skip comments and errors. That's what I want. Skip comments and errors. This is just going to be something like you must really know JavaScript idiosyncrasies, red type system on top of the dynamicness of it all. You don't need to use all of the weirdness of JavaScript, though, right? Just use the subset of JavaScript that makes sense. You don't need to know all of the little things about JavaScript.
Computer restarting in 5, 4, 3, 2, 1. Shutting down now. Closing unsaved documents.
Or sized integers represented. And int32 is represented as the regular number type. And int64 is represented by the big int. So the only question, so like it is good, it works. The only question is what happens when you do the overflow, right? So right now, I'm saying that overflow is undefined behavior. What if you want tightly packed bytes? I have not wanted that yet, so... I guess you would use the byte buffer, or what's it called, like array buffer in JavaScript. Then you can have the bytes directly. That's what you use when you are dealing with WebAssembly anyway. Or use crane lift. I still believe that crane lift is more work than JavaScript backend. And from what I have seen, the QBE is even simpler than crane lift. QBE versus crane lift. QBE emphasizes extreme simplicity, right? Like, they are both much smaller than LLVM, but QBE is even simpler. Yes, anyway, I'm not going to go for those. I'm going to transpile to C. I think that is even simpler, but I'm not sure if that's simpler actually, but I like the idea of transpiling to C directly. Instead of like, because QBE has limited support of the platforms that it supports, right? So if you generate C directly, you have like more potential like targets that you can do. How do you do CPS in C? You like, I mean, first you need to figure out how to do the closures in C, I guess. Which means that you have like a function pointer plus the pointer to the data. And once you have the closures, CPS is like the regular transformation, I guess. you can do it like you can first transform your code to the CPS even before going to C, and then you need to transpile that. Yeah, I'm targeting C after self-hosting. JavaScript backend becomes reference compiler. Yeah, basically. Well, I mean, there's probably bugs in it too. I do know a couple bugs already. Like I don't support. I don't do the copy semantics at all right now. Everything is treated as a move type, and then I'm like abusing a little bit the fact that I don't have the borrow checker. But it's okay. We are pretending that the code is like the way it is. Like for example, right over here, I'm having the reference to the array list. But even if this was not a reference, this would still be passed by reference, because that's how it works in JavaScript. But it's okay. We've looked at it before, and there wasn't a 15% performance deficit until common workloads. Yes, but is 15% bad? Like, if I am going to be like, I feel like even if I am like 5 times slower than like C, then it still is good. Right? It's like right now I'm like 1,000 times slower. And my interpreter is like 10,000 times or like 100,000 times slower currently. Dun, dun. I mean, shitty F32 performance is bad. I don't know, is it? I mean, the programs are being written in JavaScript. I mean, yes, they are more like slower than what you would write manually, but like the whole world works like that, and it works good enough. So why wouldn't it not work for me? Right? Like, I am prioritizing here not the performance, but the development time, right? So that I can have something that works. And then eventually, once we have developed something that works, we can think of the waste of electricity, yes. The waste of memory and CPU cycles. Those things can be thought about once we have something working. Because right now it's a premature optimization. Well, it's not really premature because like I can feel the speed there over here being slow. But I mean, over here, actually, the thing that is slow is the stuff that's like it's the compiler written in OCaml, which compiles my parser right now, which has how much code have I written already here? Let's take a look. 2,500 lines of code, right? So this is compiled in what was it, like 5 seconds, I think, or something. Still should have targeted C. That's what I'm saying, right? C is a good target, yes, and I will target it, and I will replace the JavaScript backend eventually. I will get rid of the JavaScript backend. It's just a lot more work. JavaScript is so much easier. C is a trash target. What is the better target? I have just told you why C is better than like QBE. And the same applies for crane lift, and I guess even LLVM. One of the advantages is the amount of targets that C supports. Because LLVM is just one backend, like just one of the things that can compile like your C code, right? There's also the GNU compiler, which I think targets some targets that LLVM does not. So by having the C code, you can use whatever C compiler. And there are some like exotic C compilers for some exotic targets, I guess, too. C being trash doesn't matter. Yeah, exactly. C being trash doesn't matter. Same as JavaScript being trash doesn't matter when I'm making a language. For now, it doesn't matter. Skip comments. JavaScript being trash does matter. It depends on your goals, right? So like, JavaScript is better still than C because it requires less time to work on the compiler. We're not trying to make the ideal compiler yet. It's a temporary solution so that we can work on things. It makes sense to do that. When I get to memory management, good light fighting C. Fighting JavaScript. Sure. What do you mean about memory management, though? I don't need the raw bytes. Like, that's like also the point of the language. I'm supposed to be to abstract away the raw bytes. There are certain things that C allows you to do, like pointer arithmetics, that, like, it is limited. Not all of it's not like I want to abstract from it. So that, you know. You don't need to manage memory. No, I will want to manage memory. It's not really a functional programming language. It's a regular programming language. It's a multi-paradigm programming language. It's not just functional. And there are functional programming languages that can be low level, which manage memory, yes. It just, most of them just use the garbage collector instead. Like what language? Does it use do notation? My language does not use... I mean, my language is basically, you're always in the do notation, kind of. I guess. I don't know. One of the languages... I mean, there's... Yeah, I don't know. Maybe there is other alternatives, but there is the anti-lang, for example. This one is in the works. So... their website is not opening. Wait, Google... No, Google is opening. Oh, it's anti-lang without the dash, right? Low-level functional language. With the move semantics similar to Rust, but different. There's probably other low-level languages. They don't do the do notation because they are also making the effect system, just like I do. So it's not monads. It's instead tracking the effects. Which means that you're basically always in the do notation also. Comments and errors. Is this function used? This function is not even used anywhere. Try parse or extend minimal. Keep comments and errors here. And then also when I'm trying to parse the single rule node, I want to skip comments and errors over here. All right, now we cannot finish parsing underscore with underscore. Okay, I am like literally at the end of this file. Right, so I have parsed this thing. Right. I cannot finish parsing underscore with underscore. Right. So the reason is that we are ignoring the priorities for now. You can customize the syntax, perhaps even more than creating the new operators. Yes. All of the language syntax is done by customizing the syntax. There is only one built-in syntax in the language, which is the syntax of defining new syntax. Everything else is like a library feature, basically. And that's what I'm working on the parser for this thing. So we are almost done. The only thing that is left, kind of, is me. I'm currently ignoring the priorities of the rules. Right? I'm currently ignoring the priorities of the rules. So what I want to have, I have the context here. Rule set token stream interstitial span duty. That means that you need to use an interpreter instead of using compiled front-end parsing. Depends on what the interpreter means. I mean, not really. Not really. Because you can I mean, technically it's possible to generate the code that is parsing the things, right? But the parser that I'm doing is doing the parsing at runtime, right? Like the parsing rules are parsed at runtime. They are not known at compile time. But you could, instead of doing this, you could generate the code for parsing. That's what usually the parser generators do, as I understand it, right? You have the syntax definitions in some way, and then they generate code for you to parse the code based on that definition. But because I want to extend the syntax at runtime, I don't do that. Which might have like problems with performance, but my problems with performance are not in the parser, they are in the compiler, so it doesn't matter, it's whatever. But also we can do like and like it's not really interpreted, right? Because I'm like I mean, it depends what the interpretation means in this case, right? Because we're not doing the interpreter for a language. We're doing the interpreter of the syntax. Whatever. Right? So, yeah. I guess you could also have some form of like a just-in-time compiler of the syntax so that it is also like fixing those potential performance issues. So what is missing here right now? Whenever I want to parse something, I need to parse I need to parse with the maximum priority, you know? Not the maximum. Yes, maximum priority, right? No, not the maximum. Minimum priority. The priority filter. There we go. We have priority filter, which is going to be any. So like on the top level, we can parse any AST node. But when we like, in the simplest example of the math operators, right? If I have the plus, then on the left-hand side and the right-hand side of the plus operator, we can only parse the things that are higher priority, right? Well, since plus is the left associative operator, on the left-hand side, it is more than or equal than the current priority, and on the right side, it's only strictly greater than the current priority, right? So that's what we should do. We have the priority filter of what we can parse. Priority filter. Syntax. Rule. The runtime you're talking about, is it just to convert the code into some executable format, or you always need to parse before running it? There is nothing executable. Parser is just parsing the code into the structured syntax tree. We are not even executing anything here. There is nothing to execute yet. Try parse or extend minimal. What do you do with the AST? You compile it then into the intermediate representation, which then can be interpreted or compiled further into the binary target. Or not binary, but like JavaScript, right? So the language works like this. You have the source text, which then gets like using the lexer, you convert this into the token stream. The token stream is then using the parser, it's converted to the AST. Then we have the compiler, which turns this into the intermediate representation, and then we have the interpreter, which can run the code, or we have like the you know, like code gen. So it's either interpreter or like the actual code gen backend, right? Which is like JavaScript right now, but it could be like C backend or LLVM or whatever, right? So this compiler over here is not like the compiling to the target thing. That's what I'm calling the compiler. Imagine writing the binary directly. When I try parse single token, the priority filter does not matter. But when we try parse single rule node, we do have the priority filter. Right, so this is where we should know, like I'm trying to follow with the keyword. here, I'm trying to follow with the keyword, and if by following this keyword, like I'm having the edges here, right? The edge map, right? Which has the value priority. And value priority is this is the value priority of the specific value when I'm following the edge. But what I also want to have is I want to know the minimum I want like the maximal priority of all of the rules that can be reached by following this edge. Because if we cannot reach anything which matches the priority filter, then we don't even try following there. That's the idea here. So this information doesn't even need to be on the edge technically, I suppose. It could be on the node, you know, over here. Maximum rule priority. Actually, you know what? Let's do it on the edge. Maximum rule priority. Syntax rule priority. And this value priority is like the edge value priority, by the way. Just so that it's more clear here, like... Well, I mean, it is already inside of the edge, so yeah, I don't know, it should be clear. Maximum terminal... Maximum... I mean, the rules are always in the terminal, yeah. Okay, maximum rule priority. So when I'm creating a new one, I will say that the maximum rule priority is equal to the I do have the context here. Rule, syntax rule. Let's have this. You know, let's have current context rule priority. Syntax rule T. We have rule priority. Right. So we have the edge. And the edge priority, like, yes. This one is what? This should actually be called the minimum priority, right? Or is this still the maximum priority of the edge? Seems like I'm also calculating the maximum. Let's rename that one to the maximum too. This is the value priority, but the field is going to be called maximum value priority. Like, I feel like this deserves a comment, actually. So this is the maximum priority of values parsed by this edge only, right? And this over here is the maximum priority of filter of values parsed by this edge only. Maximum priority of rules reachable from this edge. There we go. I added a comment. So now over here also we need to like maximize, compare, and to compare the priority. How do you any RMP based PCs? How do you? What do you mean how do you? I don't have any ARM based PCs. I mean I have the I have a Raspberry Pi here somewhere on my desk, which is ARM, I guess, but I'm not using it for anything. It could consider a mini PC, I guess. I even have the monitor on it, the little tiny baby monitor. I don't know what to do with it though. It just lies on the shelf forever. Eat it. That's why I'm running Windows ARM, just so that you, just so that you do something with the piece of thing that you bought, so that you didn't waste money, right? Maybe I should try to install Windows on it. Why is ARM good? I don't know. I mean, Raspberry Pi is and the old ARM, the new ARMs, which are like the Mac, the new Apple chips, right? Apple Silicon. Those are supposedly good. I have not tried them myself, but the idea is that they are performing well and they don't heat as much, right? As the x86. I don't know. Is that like because of the architecture of the ARM? It somehow like does less heating, or am I imagining? I think that's what it is, though, right? OS IWS has ARM for cheaper than x86 now. Yeah. Yeah, but like I mean, ARM is different, right? They're like the question. Like I could see like a Raspberry Pi ARM chip would be cheaper than like x86, right? But what they sell is probably like the modern ARM chips, which are also performing well, right? So they are also cheaper to make, I'm assuming, is what this means. Is that true? They require less maintenance because they don't overheat as much, which is why it's cheaper to run, right? They're better optimized for portable battery powered devices. Yeah. They don't overheat, they use less power, which is like connected. Some genius said us make those bigger and put it in a computer. Is that sarcasm? Do you not like that? Or is that not sarcasm and they actually are genius? I don't know. I don't know much. You're upset that Apple was the first to do it? I see. Yeah. But are the other ones doing the... Wait. Is there anything else than the Apple Silicon that is... that is ARM? I think they were not the first ones, but the other ones were like very, very like niche or something. Right? You can't imagine Amazon is buying Apple chips? No, yeah, but ARM chips. What is the current? I mean, they have their own chips. Amazon, Oz Graviton. What am I doing here? I'm saying that if Edge, if context rule priority is more than Edge max rule priority, rule priority is this. Okay, so back to Parser. Back to the Parser. We have this edge here, right? We have this edge. And what I want is I want to know if we should even try following this edge. Both with keyword and with value. So we should have something like should follow edge is syntax rule set edge boolean, right? This should just return edge max rule priority matches the filter priority filter syntax rule priority matches the filter. And that's what I want. So we have priority filter, and we want priority matches filter. So it's priority. It's priority. Filter is priority filter. This returns boolean. So we're going to match filter. If it is any, then it's true. If it is greater or equal of the minimum priority, then it is priority. More than or equal than minimum priority. If it's greater, then it's just strict. Priority matches without the filter is fine. Max rule priority. Why do you guys use laptops? I don't use laptop. I have a laptop and I literally don't open it. Like, that was another waste of money. The first one is the is the Raspberry Pi. The other one is the laptop. I mean, I used it like a couple times when I was traveling, but I don't travel much, so it's kind of a waste. And also it's much slower than my PC. Should this be the maximum value priority or should this be the minimum value priority actually? But over here, when I'm trying to parse the inner value, I need to say that priority filter is edge max value priority. I feel like this should be minimum though. Oh, this doesn't make the AST available if I do the parentheses. Makes sense, I suppose. Cannot read properties of undefined reading yet. No! This is the actual miscompilation, is it? This reference. This context rule. Oh, wait. Wait, how is this even compiled? This is supposed to be... This is supposed to be the context. Wait. Oh, it's not here, right? It's in the syntax rule set. We have context rule. How does this compile? This is not supposed to compile. This over here is supposed not to compile. I have a bug in my language. Or something. Because the type is supposed to be context. I mean, the type of this context is supposed to be this thing. And I did not specify the rule. Let's fix this bug maybe real quick. Like, this should be easy. Isn't this just, like, when I'm initializing the, like, this is the inference, when I'm having inject context. Yeah, I have the inject context, and it does not require the value to be of the correct type. Right? We have the context type here, and I have like context type, and like value, data signature type, inference type, expect inferred as this type in the current span. That's what I need to do. Like, literally one line was missing. Let's see. Like, if I just try to do this, it's going to complain, right? It's going to complain over here. Right. Nice. Okay. Type check inject context expressions. How's Linksider going? If we keep not working on the Linksider for a little longer, then we might as well just rewrite it in Kast. I don't know. I'm waiting on the team to assemble, you know, so that we work on it all together. I mean, maybe I should just work on it like alone, but that is a little sad. You know, people have life. What's left? I guess some levels mostly. Maybe a little bit. Yeah, like it's like the level design stuff mostly. I don't know if there is like much for me to do actually. I would just work on some polishing, maybe improve the performance, maybe like we rewrite something from scratch. Like the chapter selection would could probably be better. So yeah, most of the work is like just coming up with the levels. I have made a bunch of mechanics which are not used in any of the levels yet. I could always like implement new mechanics, but like if no one is making the levels, then yeah, I could make the levels myself, I suppose. But it's just nicer when like, you know, everyone works. Into Park Dave, you got it? Yes. Okay. Parser. So this priority filter, we have this function should follow edge, but I'm not using it yet, right? I should say that I only do this if I should follow this edge. should follow edge, edge. Then we do those things, you know. And over here also, if we have the edge, if should follow edge, edge, then we do these things. All right, let's see if it's going to be parsed correctly now. This is probably still buggy. Expected end of file got at identifier. Oh, right. This is not correct. um, and to fix this bug. Let's fix this right now, actually. Hold on. Cannot be awaited. Hello? Awaited. Oh, I in the wrong repository. Awaited. This thing. It says fail. Fail format. Fail format is like... Okay. Over here, right? That's because I'm doing it to the string formatter. Actually, I don't know how to fix this. Let's not waste time. Let's ignore this bug. Too many values when I'm collecting the values for core function. Too many values applied for the rules. Too many values. Wait a second. Rule part is this. No, this is not enough values, right? Do you shampoo your hair before going to bed if you use gel? You can just use water. Too many values. Like, this is not too many values. This is not enough values. Oh, wait, no, this is rule part. Yes, this is rule part. But why is it when I'm collecting the values for core FN? Too many values. Let's also print the parsed parts here. What am I trying to collect there? Right? We have this. We have JavaScript self. This token shape. Right? I have parsed this thing, basically. And it says too many values. But why? I'm trying to parse the core fn. Like, because this is correct, right? We just have the match as the last thing. This is supposed to work. Because the syntax says that core fn, this thing, right? So we don't have async, so this group is skipped. We have the argument. The argument is this first part. Then we don't have the context part. We have the result part, which is this arrow. Okay. And I have the body. And also, like, oh, maybe like some of the inner parts are that. Oh, yes. I should like say that over here I'm collecting the values from into. So this is the group parts. Let's call this not rule parts, but like rule. Let's call this rule group parts. Rule parts. Rule group parts. And this is like rule group name is option string. Is it like a string? Rule group is optional syntax rule group. Is that what I do? Like over here, let's say that rule group is none. And then like over here, let's say that rule group is some rule group. Just so that I can report the thing better. But the rule group I would like to know the span of it, I guess, so that we can figure out and like do the error reporting span. So in the syntax parser, we do group, read group. This returns the group. I need to give it the span here. Start. Let's say first token is token stream peak, and last token is token stream peak. But if it's question mark, I guess, then we're just going to modify it like that. So span is start is first token span start, right? end is last token spans end. Yuri is, I guess, first token span Yuri. Let's do that. Boom, 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 boom. Panic too many values. I mean, I just do report and unwind, right? Error, report, and unwind. So the span is going to be... I need to know the parsed part span. Do you think it would be a good idea to make a language that generates source code based on IR and you program in your preferred frontend? Generate that IR, but all frontends have the same IR. If you never really use the source, it's just some sort of visualization. I don't really think that it's like a very good idea, but it is an idea for sure. And I think that such project exists. I don't remember. What was it called? Like, they don't have multiple backends, but I think the Unison language, maybe? Is this the one? New approach to distributed programming. So the idea here, I believe, is that, like, they store code not in the source format, but in, like, a different format. Right? It's not like... Exactly. I don't know. Your code base always lives and type checks even in the middle of refactoring. A new approach to storing code. Other tools try to recover structure from text. Unison stores code in a database. This eliminates builds, provides for instant non-breaking renames, type-based search, and a lot more. Right? Something similar to what you were talking about. Okay, the span here would be the parsed part. Span. Too many values for and it is either for like for the rule, right? So we're going to match the rule group with none than for rule. Otherwise, if it is some group, then output right rule group. If group name is some name, then I'm also going to output right group autotype name. And we also want to print the span, right? So output right at span print group span. How do you present in C++ the garbage collection? Isn't there like the thing that is like C++ for .NET, which has the garbage collection? That's I don't know if this is being used still, like C++ .NET. It was called as managed C++, and now it's called C++ CLI. Like this is a specific project. It's a language specification by Microsoft that extends this C++ to support the .NET framework, and like because like that works with the garbage collection, you can do that, right? So there you go. This is the garbage collected pointer, I guess, right? And then you have this over here, GC new. But I mean, the idea of bench chilling is not to work for existing languages, but to create a new language where all of the things, like optional ints, exist in the IR, so that like it's just the front end. Like, I don't know why would you create a language with multiple front ends though. I mean, technically, like LLVM is such a language, right? It's just very low level, basically. Like, it's not a language anymore. But yes, you have the front end which is customizable. Then, so what if you like? What if instead of LLVM, because it's like low level, what if you had the higher level intermediate representation, which is, since we were just talking at the looking at the C++ CLI, that language is basically the common language infrastructure. That's what the CLI is. So that's already what you want, right? It's basically like the JVM is the same thing, right? Because you can work in the JVM with multiple languages, like with Kotlin and Java in the same like code base, basically, right? Because those are just front ends for the JVM, same stuff, right? It doesn't have a good interface. Why does it not have a good interface? Let's see, too many values for the rule group result over here, right? There you go. Now we have a better error message. So the result is this. And why do I have too many values? Oh, wait, no, that makes sense, right? It actually makes sense here. If we have too many values, then I just skip the group. Yeah. I literally just need to say that we need both the parsed index to be less than this, and the rule part index also needs to be less than the rule group parts. Which means that this is not even a thing. Right? I'm literally just trying to match that. There we go. You cannot just assume that tagged union with an int inside was supposed to be an optional int in Zik. You cannot. So now we have the mismatch. I'm collecting values for core function. We have scope, string, core match. I mean, that's the same one, right? I just have a mismatch. Why do you have a mismatch, though? Like it's supposed to not be the white space, so it's either keyword, group, or value, right? Language unspecific IR to the source is just not possible. Well, if you restrict the languages, then it is possible, though, right? Like, you can't decompile the .NET stuff, and it will show you the C# source code. That's what the decompilation is. But the language becomes irrelevant, yes. I guess. Well, and you can like decompile like an optional int, but then it will be like decompiled as the raw representation instead of like the high level structure, right? Like you need the opposite of lowering, creating assumptions and things. It's, yeah. Low universal languages are more low level by definition. Yeah. Yeah. Like, I think I can see the value of storing the code as the structured data structure instead of the source code, right? And like I said, that's what the Unison language is doing, apparently. Right? So they don't recover structure from text. They do it like in the opposite way. Once you want to edit the code, you reconstruct the source and then like do something. But I don't know. Incorrectly matched keyword. What am I trying to do here? I'm trying to understand why do we have a mismatch? Why do we have a mismatch? I need to print the part. Print parsed parts. I mean, I do have the print parsed parts. I want to know what is the part that I'm trying to match with what, right? Like, I can give it the already parsed children. Let's say mismatch. Matching parsed part number parsed part index and rule group part number something. Rule part index. I should also make like the debug logs if I'm trying to parse the optional group or not, right? Or like if I'm trying to parse the group or not in general, right? Log info parsing. Okay, matching group. Matching group at rule group span. Let's just do that. And over here we say like log info message group matched. Creating a custom view over the IR. Yeah, like why would you need a different view than like the view that the language is giving you? Do you ever want that in any of the existing languages? Maybe. Like for example, let's say that we are working on, if it's just eye candy, why even bother? Like, imagine that you are making a game like in the Unreal game engine. They have this thing called blueprints or like whatever. Like the idea is that you have like visual programming where you have blocks connected with the arrows, so you like visually can see the dependencies, for example, and how spaghetti your code is, instead of viewing it as actual code. You know? Because otherwise maybe you want to have actually the some tool that creates this visualization for you, but that means that we like first parse the source code, convert it into the intermediate representation, and then converting to the other representation, like those things already exist, right? So the idea is that just you don't go through the parsing stage because you already are in the intermittent representation. I don't know. What's the reason to do that if you are... I mean, the reason to do that if you are mostly working not in the source code form. Right? But if you are writing code as code and not as like some other thing... I don't know. It's an idea looking... It's a solution looking for a problem, I guess. Mismatched parsing, parsed part number 4 and rule group part number 5. Right. So I'm collecting the values for the core function. I'm matching this group result, right? This group has been matched. So parsed part number 4. Number 4 is what? 0, 1, 2, 3, 4. This is the one. And this should be the rule group part number 5. And rule group part number 5 is what? We have, this is the first one, the second, 1, 2, 3, 4, 5. No, it's 0, 1, 2, 3, 4, 5. It's because I'm matching it with a keyword. Right. Wait, is it because... Wait, what? But why? It's because I have increased the index for some reason, or without needing it. When I say this continue, it continues which loop? Like this loop, right? If not should match group, then we continue. You know what? How about we do more logging, right? That like over here, since this matched, right? Let's do log info matched keyword keyword. Oh, you know what? I'm actually going to say log info. I'm going to say meshed keyword, and then I'm going to say token print token, because this will give me the span of the token, so I know like where it is in the source code too. Right, like over here, right? I matched, yeah, so I matched this keyword, but then I'm trying to match that one, right? Let's also do this here. Matched value. And over here, I'm just going to print the span of the AST. Let's also do over here debug print parsed part. and the rule part. That's a lot of logs now. Right, so I'm trying to match the keyword list to that thing. Okay, yes, the parsed part is too much. To look at. All right. Core match value self group matched mismatch parsed part number 4. So I'm not matching the keyword, right? Like, why does this happen though? It happens because I have skipped over this token somehow when matching that group, right? Right. That actually makes sense. Look at this. It's because I have matched the group, and after I'm matching the group, I'm also doing this. And this is the bug. Okay, I just need to do a continue here. Or we can say something like this. We can say something like this. Instead of doing this here, so this means that I have matched the group, so I just need to increase the rule part index. Let's just do it explicitly in every branch, right? So when I match the keyword and keyword, we increase both indices. When we're matching value and value, we increase both indices. When I'm matching the group, I only increase the rule part index. There we go. There you go. Okay, I have parsed everything. Okay, now the question is, have I parsed it correctly or not? That is a question. We have a lot of output. We have a lot of output. Is there a command line utility which gets rid of escape codes? Get rid of escape codes in a file. You do SCD like this using call. If the file has backspace or basic formatting, the call utility can often clean up. What is call? Do I have it? Filter reverse line feeds from input. Do not output any backspaces, printing only the last character written to each column position. Okay. Like, can I do self cast and into call B? And this is going to get rid of my syntax highlighting. So I don't need to like change my code. Wait, what? No, that is wrong. You have to use the SCD then. Like that. I also want to SCD the vertical bar. This one. Into nothing. we save this to output. What computer do you use? I need to get one that compiles fast. My computer is not very good. It's pretty old. I'm using the Ryzen 5 3600, which is old. I can get like twice as fast, at least, with the better CPU. What, are you tired of compiling your C++, waiting for it to compile? All right. Let me see the output of what I have parsed so far. Okay, look at this. So now that I have parsed this into a file, I can like fold it properly. That's why I did it. Okay. Let's see. So this is the parsing of the source token, right? This file is being parsed into that, right? Yeah, I guess it's like because we have the then, right? Because this is the binary operator, like the semicolons have a lot of nestiness because of that, right? Yeah, that makes sense. Actually, why there is this much nestiness. And so in order to get rid of this nestiness, I am flattening these ASTs later when I'm compiling them, but maybe we could have the this functionality in the parser, right? So the idea is to have the repeated groups, have a new kind of quantifier. How do I know that this is parsed properly? I just need to like look at it. So we use .star import output KS, right? A bunch of these things. Your C++ code is more nested, amateur. Yeah, I think I have parsed successfully the code of the Kast with Kast. I think I've parsed it successfully. Let's also try to parse the JSON. How about this? We need to parse. The rule set is tests syntax JSON. All right. So we cannot parse the cast file with the JSON, right? We need some JSON file. I need some JSON file. Some JSON file. Let's do this one. Let's do project castlang cast lsp stress test init JSON. This is a JSON file. It's parsed. Look at this. I've parsed the JSON. It doesn't look like JSON because like we need to process this parse structure later to convert it to like the actual thing. But yeah, there you go. Let me open that. Right? So in this file, in the end, somewhere, we have these workspace folders. So we have a field workspace folders, and the value of this field is a list of elements. And there is only one element, which is the object with two fields, Yuri and name. Okay. This is nice. This is nice. How about we like work on the JSON actually first? Because I can further process this output of the parser to construct the actual JSON object. I guess. There's probably like some more issues, but Kast is kind of parsed. We will try to like there are things like extensible syntax, right, which I already use in this project right over here. This is not going to be parsed currently, but this is actually pretty easy to add. But let's first do the actual parsing of JSON. How about this? We will have the actual object JSON. Use, and I will be able to like print it. So we want to have the JSON. The JSON type is we either have a list, which is list of JSON's objects, right? Or we have an object, which is a map. So it's an ORD map from string to JSON, right? Or it is a number. And JSONs only have the floating points, right? Wait, what is like the specification of JSON? Specify there for the numbers. Just floating point, right? And then we have strings. Anything else? There's also null. Is null part of the JSON specification, actually? I'm not sure. JSON spec. There's also true false. Number, string, object, array. They call it array. They call this object. Let's call it object instead of obj. Number, string. Let's do it in the same order. And then true false. Is that not a boolean? Let me call boolean. And null, right? Those are all the things. But what about the number? I'm just wondering, what is the number? Number is, we potentially have the negative and then some digits. And then they also support the E, this notation. They do not support the nuns though, right? The none is not supported in the JSON, I'm pretty sure. Anyway, this is the definition of the JSON object. Hello, borrow check. Hello, borrow check. Thanks for the raid. I am at the point where I have parsed one of my Kast sources probably correctly, and I'm trying to use the same parser to parse not the Kast source code but the JSON. We started from zero. We did some design stuff and didn't like the code base, of course. Redo the whole thing. Okay. Are you doing it with AI again, or like in the human way? Human way impossible at this point? I don't know. I'm doing it the human way. I don't know. I don't know. I don't know. Maybe your project is more complicated or something. Like you smarts? I don't know. I don't feel like I'm doing anything very smart though. Like it's like, I don't know. I mean, maybe I am smart, but I feel like it's like nothing special in what I'm doing. Kind of, right? Like, in fact, I'm doing it the lazy way, like even with the parser here, right? The way that the parser is like very, very generic, kind of, right? But I'm doing it because I'm lazy. That's why I was doing it this way, because like writing the parsing of all the things manually, that would like actually be taking more time, I feel like. All right, so I have the JSON, and what I want is I want to say like, you know, JSON parse. JSON parse. Good night, Borchak. JSON parse. So I'm actually going to use the parser here, right? So parse is just parsing the string as a JSON, and this is going to return the structured JSON, potentially with an error. JSON, that's not a trip. Yeah, it is not a trip. Result, parse error. And we have the parse error, which is just I don't know, maybe it just has the message. And I guess it also has like the span. Sure. The span without the source file, because it's just a string. Should I have like a span for like the one without the files, the range? Right, that would be called the range, I guess. The source range, maybe, or something, or it could be position. Okay, so we have parser.parse. Parse returns the parsed. So we need the rule set and things as the arguments. So the rule set is equal to JSON rule set. I mean, I just going to have the rule set here. This is so over here we can parse the JSON rule set at compile time, actually, right? We can say const rule set is, so we need the syntax parser first. Rule set is syntax parser. Do we have syntax parser, like parse rule set from the file? Power syntax rule set. It takes like the token stream. Fine. Let's do that. Token stream is token stream. Does your language have a predefined list of method operators, or are they constructed by the user, like their functions? And you create operator overloading for them. They are created in the standard library, in this standard syntax. It's like, which is basically the library. You can define your own syntax. You can define your own operators. And things like that. The standard math operators, they are defined in the standard syntax, though. And right now they are the sugars to, like, basically this is the syntax sugar for something like a plus equal b is syntax sugar for a is equal to a plus b, and a plus b is syntax sugar for std op add a and b, right? Which also has the generic argument, which is going to be inferred. So yeah, something like this. And then we also have the ability to have like something like traits, so which is going to be the way that you can override the operators. But right now I don't use them, so it's like polymorphic, a little cursed, but whatever. Every user of Kast has standard library. Well, standard library is embedded in the language, I guess. But I mean, technically you can do this. You can do Kast no std like this, right? So this is going to drop me in the REPL. Wait, what? Kast no std doesn't work anymore for some reason. All right, anyway, like I guess I can say something like this, you know. So if you do like 2 plus 2 and then Kast eval, right? That is going to print 4. But if you do Kast no std eval, Kast eval no std, I guess. Is it like that? Yeah, there you go. Then you see then that the plus syntax is not implemented. So we are trying to compile the plus, but it is not defined because it's defined in the standard library. So if I try to like evaluate it without the standard library, then the it's not defined, the semantics of the plus operator. KS is my programming language. It's called Kast. Hello, white demon. If you use no std, how do you create the idea of additions? Similarly to how it's done in the standard library. We already have this, right? Like for example, in this, because I have didn't have like the indexing operator in the standard syntax, we have defined the syntax for indexing here directly, right? So over here, I have defined the syntax for indexing an array like this. And then I'm implementing the semantics of the syntax as this. So this is like a macro. So we basically rewrite this code into this code, right? And similarly to that, you can define the semantics of the plus operator or any other operator. There is certain like syntax that the core compiler is understanding, right? So not everything is going through the rewrite process. Some of the syntaxes are core syntax, right? So, but it's like basically based on the name, you can have the core syntax with the different like keywords, for example, right? It's just that the compiler expects like the syntax to be parsed into the structured object with the same like fields, right? So over here we have name and impl, right? So which means that if you define your own syntax for this core thing, then you must use the same names. Because the semantics of the core things defined in the compiler. In Kast, you write something that transforms to the JavaScript, and JavaScript contains the idea of addition. Yeah, that is another way, right? We have the ability, like one of the things in the core syntax is the ability to have the native expressions, native, right? Like over here, native. This is native to the compilation target. We have right now two targets, which is the interpreter and the JavaScript, right? So, like technically, you want like to have the it's like target dependent, which we also support. But when I was making like the game, right? So right now I'm working on the JSON parser using the Kast parser. But we did not have the JSON parser as the library before. But because the JavaScript already has the JSON parsing, we can just use that directly, for example, if that makes sense. So similar thing could be done about like the other math operators. Let me open the code just so that I show you. Like for example, I don't have in the interpreter the definition of what the sine or cosine functions are for the math, right? Which is required to write a game, right? But over here we have the is it in the common? Maybe it's in the math somewhere. Like look at this, right? So I am saying that float, like square root of a float, is just implemented directly in the JavaScript. You could do the same for the math operators, right? Later, I will actually make this to be also implemented in the interpreter, but I guess I'm not using the interpreter that much anymore. Do you value your personal interpreter uses the technique? What technique to have your computer do the add? So the interpreter has some native things implemented, and then we just use the same way to, so like we have a way to talk to the target in the form of the native expression. So if it is interpreted in the interpreter, then it basically just sees the string, and the string says add, right? So that is being evaluated in the interpreter to the function that adds the things together. But when it's compiled to JavaScript, then like it's the JavaScript that knows how to interpret the native expressions. Anyway, I'm trying to do the JSON parser. And I was like, token stream new. Token stream from function. How do I control the token stream again? Like this should be extracted to a method. It's just like the lexer, right. Yeah. We have something like this. But in this case, the lexer is having the source, which... I mean, in this case, I actually read the file, and the file is going to be here. What LSP am I using? My own LSP for Kast, because I'm writing Kast. cd path, dir name of the file, plus dot tests syntax JSON JS. That's what I'm trying to parse here. I can move this file later somewhere else. So we need a Lexer too. And I need the token stream. Okay, but in this case, the token stream is going to be, we are also going to create the Lexer. Right, but in this case, let's say source, let's say Yuri is, Yuri path, JSON, like this or something. Source, I need source too, right? I need syntax parser. No, I do have syntax parser. Parse syntax rule set. All right, entire source span is source. Source is source. Contents is JSON, and then we have the Yuri. So entire source span. Let's make something like source entire span of the source, and then I have the Yuri. Okay, that should work. So then we parse. This is going to be parsed. Source use span use position entire span is source into span. Yuri is self Yuri. Start is position beginning. End is position is position beginning. Position for C in iterate self contents. Something like this, right? Self cast parse JSON is what I will want to do. Like this. Okay, Yuri no such file or directory over here, right? Because Yuri is in the depths, Yuri source lib. Slash can't await function to be compiled. Which one? Picked is f from function f. This over here is not compiled. I cannot do this at compile time. Really? I cannot. Why not? This over here is not compiled yet when I want to try to use it. Which is weird. Maybe I don't yeah, maybe I actually like require this to be evaluated immediately. This is supposed to work eventually, but it doesn't work right now. So let's instead do const rule set is a function that returns this rule set. So we will say that rule set is a rule set, which means that I'm parsing this at runtime after all. You have two libraries in Kast and you want to make a third one, and your first has C-like syntax with manual memory. Second lib is similar to Go and has GC. How do you reconcile the two syntax in the third library? I'm not planning to do that though. I'm planning like the language to be the same language instead of like different languages. I mean semantics, right? So the syntax is just syntax sugar basically. The core syntax is still the same there in both of the languages, in both of the files. You can use like the different like syntax, but it all needs to come down to the same core syntax anyway. In a way, it's similar, yeah. I don't really like like the idea of the custom syntax is not that you completely rewrite the syntax from scratch. The idea is that you can extend the syntax. Like for example, right now I'm parsing the JSON, right? And what we can do is that we can embed like JSON into the source code, right? Similarly, you can embed the SQL into your source code so that you can like instead of embedding it inside of a string, we actually can parse it with the parser to have syntax highlighting on it and like all of the other things, you know, when you want to embed another language in your language. Why you're writing JSON? I'm writing JSON just to test. I'm going to use your JSON for the thing anyway, probably. I mean, we will compare our implementations, I guess, right? Like, one of the things is that my JSON parser is going to use the Kast lexer, and your is going to, like, actually work with proper JSON, right? Well, I mean, I could change the lexer, of course, but yeah, whatever. So my JSON parser is not going to parse all of the JSON. It's supposed to be used as the, like, to embed the JSON in Kast, kind of. In which case, I think we want the same lexer as the Kast lexer, right? Unexpected argument parse JSON. Okay, let's go to main. Let's have the parse JSON. Parse JSON args t. Should it be a single path here? Let's do a single path. Does use type star work? No. But I could make it work, I suppose. So if we do parse JSON, then we do parse JSON. Okay. Right. And if we do the parse JSON path, JSON parse, JSON is std fs read file path, JSON parse JSON, debug print JSON. Yeah, I see. Boom, boom. Let's see here, match path with some path, then we do this. None. This is like read std in is what I want. Right. Do you know how everything is gonna fit together, or you're kind of exploring? If you change one part of Kast, I imagine it doesn't really affect other part. I don't understand exactly what is that question. Well, I mean, what do you mean everything affects every other thing? Exactly what you mean there. Okay, so we have a to-do. In a camel code base, you change one thing and everything breaks from what I saw. Well, I mean, that is the same in Rust, right? You change one thing and then you have a bunch of error messages which tell you what needs to be changed. It's called type-driven development. I like this. It's supposed to be the same. Like if you add a field to the to a type, then everywhere you use that type is going to break, right? Oh, you mean it breaks at runtime? Yeah. It's the best thing since sliced bread. Yeah. Well, I mean, right now some things will break at runtime, right? Like, for example, the context system is not present in the type, which is similar to the OCaml, where the effect system and the exceptions are unchecked. But eventually we want that to be present. Right. Did you choose your features in advance and now you're building on top of all the features at once, or you're just adding some features somewhere? You can compose the different features freely. Well, I mean, yeah, it's supposed to, like, the features in the language, they are supposed to be composable, yes. I don't know. I don't know how to answer that question. I mean, yeah. I'm using the language that I've created to write code here. Alright, JSON parse has this to do. I just need to say from AST parsed AST. And then we have the function from AST, which is taking AST and returning the JSON. Is AI good at writing Kast yet? I don't know. You can try. I don't know how to. I have never even like ran an agent or like the thing that in VS Code. Like, I don't even know how to enable it. Boom, 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 boom. But I mean, yeah, I guess the answer is that I did have some kind of understanding of what a language I'm trying to create from the beginning, but like the details are being explored, right? Like syntax-wise, for example, I have changed a bunch of syntax, and I will change more syntax. But mostly, the core idea of the language is there from the very beginning. Is there a part of the language that requires you to think in factorial complexity because it's links to many other elements of the semantics? I don't think so. In fact, I think that my language is actually pretty simple compared to other languages because a lot of the features of the language are composed of the more simple features instead of being like hard-coded, which means that, like, I don't know. I feel like it makes the language simpler, right? But at the same time, I can see how it is like the opposite. It's like similar to, let's say, like Haskell. Haskell as a language is a very simple language, but then you create a lot of complexity in the libraries, right? So you need to like familiarize yourself not just with the language, but also like with libraries. Can we add borrow check into Kast? That's planned, yes. I will add borrow checker to Kast. All right, so I'm going to match AST shape here, right? And if it is, so if this is a string which has content, right? Let's just return JSON-T here. And whatever. This is going to be string contents. We'll implement using small features, or is it going to be in the core? I like the idea of having the borrow checker implemented as a library, but I don't think I understand how to do that. So yes, I think it will be in the core. Similar thing is like the type system in general. Imagine a language which is basically implementing the type checker as a library. For example, you kind of have that in like Nix, where Nix is a dynamically typed language, but then you have the module system which kind of has the type checking. You know, something similar to that. And like in general, even like in like it's just checking the types of values at runtime. So it's more like not the type checking, but validation, right? But I feel like you can, by allowing the code to be run at compile time, basically to inspect the intermediate representation and add the type system on top of the untyped intermediate representation, like somehow. I like that idea, but I have not explored that. I feel like it's possible to create a language like this, where type checking is a library feature, borrow checker is a library feature, and like all of these things are a library feature. But how does that work with code that like does not use the borrow checker library then, right? I don't know. So like I'm planning it to be a core feature because we want that. So there is going to be no option to skip the borrow checker, actually. All right, if this is empty, then we like error. Let's have error. What a beautiful day for programming. Yes, exactly. Hello, Zend. We're writing the JSON parser currently. We're using the Kast parser. You're going to use a runtime borrow checker? No, I'm going to have the compile time borrow checker. That's the final goal is to have the compile time borrow checker, like in Rust. Similar to Rust. I have a few ideas of improvement over that, but it's based on the Rust borrow checker. The runtime borrow checker is going to be added, although probably before that, so that I don't have to implement the compile time borrow checker for simplicity, right? Like right now, I kind of have the runtime borrow checker already. Maybe not. Like I do check some things, I think. No, I don't. Forget about it. I don't have the borrow checker. Oh, this is the AST. AST is not a string, right? We have the token. We have the token. In which case, I'm going to match token shape. And if the token is the string, then we have the string. If we have the token, which is a number, do you unallocate anything currently? I'm unallocating using the garbage collection, right? Because both the interpreter is written in OCaml, which is using the garbage collector, and the JavaScript backend is also using the JavaScript. So we don't have the drop semantics yet, which is why the borrow checker doesn't really matter. Hello, CS Wine. Hi. Okay, so if we have the number, then I want to create the number, which is parsed raw number, like this, right? If I have anything else, then I'm going to report and unwind at the token span. Current output, right? JSON cannot be, and in this case we do token shape print token shape. Why is this highlighted? Expected a generic. Oh, because parse is this, right? I need to do std string parse. Could not find token in the scope. Let's import the token. All right. If I have the AST shape, which is the last one is the rule. The rule. The rule. Rule root. Well, and root is just having the children, and then we can ignore the rest. So in this case, we are going to match on the rule name. So I say if rule name is equal to object, then we do one thing. Otherwise, we do another thing. And that's what we return, by the way. Let's do panic to do here. What is this? Oh, result is not equal to this. Right. So I want to do the OK from AST. Okay. You know what? Let's try this. Parse JSON. Let's, instead of doing this, let's parse JSON like this. Hello world. Right? So this is just supposed to be... Oh. To do read std in, of course. How do you read std in? I only have the ability to read a line. So, whatever. Right. Let's have over here test JSON. Hello world. Right? This is JSON. Tests JSON. Okay, so see, we have successfully parsed. It's a string with hello world. Okay. All right. Okay, all right. So next, we need to parse these rules. So if the rule name is object, so here's the definition of the JSON syntax, right? We just have comma, field, object, and list. I just care about object and list here at the top level. So it's either this or rule name is list. Let's call it array because that's what they call them, right? Otherwise, we're going to panic, or rather, we're going to say that AST span. I'm going to say that rule name cannot be present at like is not valid JSON or something, right? Like it's supposed to be only inside of the other things, right? Okay, so this is just going to tell me, let's do test JSON as something else, you know? We say field is hello is hello world. We cannot have the trailing commas here. So object is not valid JSON, right? Because I need to do something here. Let's also have the return available. So if it is the object, then we need to return the object with the fields. We say fields is ord map new, and then we need to like collect the things here, right? So we say let's do this for field in collect this should be like instead of the AST collect iterate over the lists. So like because we have comma as a binary operator, we want to like flatten it, you know? So I want to have the binary name of the binary operator is the comma. Later we will also potentially will have the unary, like because for the trailing commas or the preceding like things, it's going to be a separate rule name, right? Unary. Say binary is comma and unary is none. Unary is optional, I suppose, because JSON doesn't support trailing commas anyway, right? Maybe for the sake of like embedding the JSON in JavaScript, though, I should support the trailing commas. So let's have AST, right? I want to say iter list. So iter list is the thing that takes the AST. That's what JSON for human thing is called, where they allow all that. I guess JSON with comments. Just JSON with comments. Is JSON with comments a standard thing? Is there a spec for this somewhere? The official JSON standard does not support comments, however several specifications and conventions have emerged. Like they have the JSON-C org. Do they support the trailing commas? Yes. So like that's the thing that we want, right? Yeah. The extension JSON should be avoided, but if it's used, it should be a mode line present in the start to just indicate it's actually a JSON-C file. Yet, if this is used mainly by like the VS Code, why don't they use the JSON-C? How's JSON-C different from JSON 5? JSON 5. JSON for humans. Oh. What do you mean additional whitespace characters are allowed? Are additional whitespace characters not allowed in the regular JSON? Yeah, also you don't have like to quote the names of the fields, I guess, right? Do you do this in JSON-C? I guess you don't, right? Yeah, I guess I like JSON 5 more then. I do like this. I do like the plus operators before the numbers. What's the extension for this? For the JSON 5? Is there the language mode, which is JSON 5? No, right? Like the I mean, I guess I need like a dedicated extension for the VS Code to do JSON 5. Which one is the one that we should do? The JSON 5 syntax? GraphQL for VS Code? Morning, Brainoid. Hello, hello. There's also SJSON. There's also YAML. Does this one add also, like, I want also the formatting for this, right? Supported file type. You just do .json5. I want the formatter though, because regular JSON is formatted. JSON 5 with syntax highlighting formatting. Parsing, validation, diagnostics, and watcher. Huh? Watcher? We can do that, I guess, also. It doesn't matter. Alright, anyway. What does detailed diagnostics mean? I don't know. I don't know. Better error messages when it's not parsed properly or something. Maybe. Alright, I want to iterate over the list of the AST with binary, which is the name. Fine, let's call this binary rule name. And let's have this to be the unary rule name is an optional string. So this is returning the iterable over the ASTs. something like this. I mean, I do have like the let rec be equal to this, right? So I guess that's what I do. And that was just the syntax sugar. So return this. Iter. No, iter is not this. Iter. No. We don't do this. We say we have the object where we iterate over is going to be. So we have the consumer, and then we do iterate self consumer. There we go. That's what we want. I mean, also, I guess I just do this here. Actually, I define the iteration here. So then I iterate over the self, and this is the AST. So we can capture the consumer here. Why can you not find iterate in scope? I feel like this should be working. Field iter is not there. Wait, so let rec is converted into this. And it says field iter is not there. Let's try to do it without the let rec. I thought I was using the let recs before. Maybe I broke something. Or maybe it's because of the hygiene, because I did it before I implemented the hygiene, and it should be like no hygiene there or something. Maybe. I just do module like this, and we'll do dot iter. Right? Like that is going to work. Yeah, it does. Okay, so we iterate over the AST. We're going to say match AST shape with. So if it is the rule, if it is the so it is empty. AST in this case we just call the consumer over the AST. If it is a rule, then root is children. Then we do something. If it is the token, if it's token, it's never this. So we just also do consumer AST. Okay. Now over here we say if rule name is equal to binary rule name. In this case, the children should have two unnamed things, right? Let's see if we can do like some fancy stuff here. Specifically, I want tuple unwrap unnamed. I want to unwrap two unnamed things from the children, right? And this is going to be the left-hand side and right-hand side, like this. And then we are going to say that I need to iterate over the left-hand side and then to iterate over the right-hand side, right? Recursively. Right. Otherwise, if rule name is... Okay, we do if unary rule name is some name if let's just do return here so that I return like that, and then we can flatten this code. So if rule name is equal to this unary rule name, then I want to unwrap unnamed, like this single inner thing, right? And then we want to iterate over the inner, return. Otherwise, we just consume the AST directly. Okay. This is it. Now, what is tuple unwrap unnamed? So this is supposed to return a different type based on this constant given to the generic arguments, right? I think I can write this. I should be able to. Unwrap unnamed, and this is going to give me like the number, right? So this is the integer. Self is tuple t, so we have the t and the n, right? And this will give me the unnamed, like the simple tuple of size n. Oh, I think I can... Wait, how do I do this, actually? I can specify the type, but... like, how would you write this code? Wait, how do you write this code? How do you write this in Rust? How did I write that? Oh, I have the fixed tuple like this, right? Yeah, like, how do you implement the try into in Rust in the standard library, I guess, is the question. Let's do the Rust standard library. Try, like, I want arrays, I want slices, right? Yeah, Kast is similar, although, I mean, Hindle Milner is like never used as is. So every language that that uses Hindley-Miller based is like lying, because like the algorithm is so heavily modified that it doesn't really, it's not Hindley-Miller anymore. I would just say unification algorithm is being used. In Rust, you also have the subtyping, so there is also the a little bit of subtyping happening, which Hindley-Miller doesn't support. I'm not having any subtyping currently, so I literally just do unification. I might look into doing the bidirectional typing combined with unification instead, because I will want to have subtyping a little bit for the lifetimes and stuff once I get to that, at least for the lifetimes. Also, you need subtyping for having something like refinement types. Yeah, trying to seems tightly hide. Like you cannot write it in the like it's implemented using some magic is what I'm like understanding, right? Like we want to have I need to look at the array after all, right? And to look array, and array should have try from this. Tries to create an array tn by copying this slice. Like this is what I want. Succeeds if slice length is equal to n. I'm wondering how this is implemented in the internals of Rust. It's implemented using try from slice copied. And what is try from slice? Reference to self. Try from. So I need a reference to array. Like where do I, like how do you actually navigate the Rust documentation to find that? Well, actually I want... maybe like try from box T is going to be better. Because this one doesn't copy the things, right? Right, like it's literally having this unsave box slice as array unchecked. Like it's basically like the transmute. And like this is a magic thing, right? Like I feel like this is basically the transmute here. Box slice as array unchecked. I mean, yeah, because yeah, you have like this from raw things, but the way I'm going to look at loop. Why does const foo is type compile, and what does it mean? A B compile. It means that you have a variant A containing the data which has variant B. Let's see. You want this? Why does this compile? Because this is the type, which is A, which is B. Like I mean, this is also compiling. You know, like some value. It's very similar to this. You know, because you can have option inside of an option like this. So this is a B inside of an A, and this is like anonymous variant types in this case. I'm considering removing the anonymous variant types, or like making them more explicit, because they lead to better messages, I think. Maybe not remove, but like make them explicitly anonymous. What is the third? It means that you have been the third person to click that button. Big codebases cannot exist in Swift? No? I mean, do they not exist? I think they exist. Wait, why did you talk? It was talking about Swift because Swift somehow has O n factorial type inference. Swift does have the subtyping, right? Yeah. And I'm not sure how it's implemented there. Exactly. There is a lot of ways to implement subtyping, I guess. One of them is to do the very slow algorithm. But from what I understand with like bidirectional typing, it will require more annotations of the types, but it will at the same time allow the subtyping to be easily checked. But I will have to look into that more. All right, so how do I do this is the question, right? I need to say that basically if n is equal, so yeah, first of all, if self named I want the ORD map. Can I go to this, please? Do I have the size? I don't even have the size of the map. Okay. Well, we have the name order, though. Array list length. If this is not equal to 0, then we have named fields. If... And then we say that if self unnamed list length, let's say that like, this is the actual the length. The length is this. If length is not equal to n, then we also go into panic. Expected expected to string n unnamed fields got to string length. There we go. Well, this formatted a bunch of things, but correctly, actually. Okay. So now that we know that length is equal to n, and we just have this thing, simple tuple. Should it even be a tuple then? I mean, yeah. I could like just get this array, but we want this to be typed. But the issue is that I cannot. Unless this is a macro, right? Because I need to convert an array into a tuple here. Okay. I mean, unless, hold on, array to tuple of size n is what we want, right? We want self unnamed. And like we want to start with index 0. Let's see. I want to write this function. Array to tuple is, we have the array list of type t and we want to return this simple tuple n. Starting with index. Right. Let's first define what's a simple tuple. Simple tuple is we have n, which is int 32, and this needs to return a type. So what we're going to do here is that we say that if n is equal to 0, then it's going to be the empty tuple type, like this, right? Otherwise, it is the type, which is the tuple, which has the simple tuple of size n minus 1. And simple tuple only has like the same types, because that's what we want, right? We want the simple tuple, it's like the same size. This is basically the fixed sized array. T is type, n is this, right? Yeah, so we have like type t and a simple tuple t n minus 1. Yeah. Like, I don't have the fixed size arrays in the language, but we have tuples and we can do like that. I guess we can rename this to fixed sized array. Even though it's a tuple. That's okay. So can I write this code though? I don't think I can. But let's try. So we say that, yeah, and then I need like this to also have n. Right? So I say that if n is equal to 0, then we are supposed to like return this thing. The empty one. Right? Actually, I don't need the index. I can start with the last one instead of putting it in the beginning. So we can say like dot 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 array to tuple tn minus 1 a followed by at n minus 1, and this takes a reference, so I need to dereference that. But this is not going to type check is the issue. Right? Because I'm trying to type check the generic functions at like not at instantiations, but when we actually define this, so the type of this is an empty tuple, but the type of this is not an empty tuple. So this then and the else branch has the different things that we do. So this doesn't work. Right? Let's see. No field 1. What does that even mean? I mean, yeah, it says like that this is not equal to that. And oh yeah, this over here, right? It should be TN. Fixed size array also is supposed to be TN. TN. Wait, why do I not see the error messages anymore on the screen? It's because it's the language server is broken. To do multiple values for key. Oh no. I have hidden a to do in my compiler. Okay. All right. So here's what we're going to do then. I would like this to work. But like the way it's done in Rust through the unsafe. I could implement this in the interpreter, I suppose, but then we need to have like the fixed size arrays also in. I mean, the fixed size array is just like the tuple, right? So yeah, but it still is not going to type check over here. Is the thing, which means yeah, but it will work if. This is difficult to implement. We could also make a macro instead of making the generic, right? Because macros are going to be like type checked later. Because this if is supposed to be the compile time if. So, like, this is the reason Zig is able to compile this, by the way, because if something is known at compile time, that it doesn't even tries to type check, like, this branch at all. Right? So, yeah. We could do the compilation model similar to Zig, where we ignore, we don't try to compile the code. But I don't think I want that. I want a different solution here. This is like dependent type stuff instead. So that we want to like type check this before we actually try to use this function. Yeah. I'm not sure how to type check dependent types yet. Like this. So we're going to not do that. Okay. So what we are going to do is we want to have a separate one, unwrapped, unnamed 2. That's what I'm doing in OCaml already. Right, so unwrapped unnamed 2 is just having the tuple, and this gives me the 2 things, you know, TT. Like that. But I can have the, you know, I can have the macro unwrap unnamed implementation. This can be a macro, right? Which takes the number, and the macro input can be the number, which is an integer. It doesn't have to be the AST, but this returns AST, right? Which which is this code over here, basically. The only question is what is self then, right? Because that and needs to be here. I guess self could be the AST. So that we like, because otherwise I cannot capture because of the macro hygiene here, right? So this would be like that. That's what we do here. We do include AST, unwrap, unnamed impl. We give it like the self as AST, and we give it the n, which is 2, like this. And now the array to tuple is also yeah. We can do that. We can say array to tuple is also the thing that returns the AST, right? So we have the array. The array in this case is going to be AST, and then the n is int, right? So in this case, we also include this one, array to tuple. So self unnamed is the thing, and we do n here. And self is dollar self, of course. AST is not found, and to say like use std AST or something, because it's not in the prelude. So array to tuple is, so over here we are generating different AST now based on the n, right? So we say that if n is equal to 0, then the AST is going to be the empty tuple like this, right? But otherwise we return AST, which is a tuple which has the array list at index n-1 dereferenced. This should be like referenced, and to have like the owning thing or something. Anyway, so this is the last element, and then the first elements are going to be the include AST array to tuple a n-1, right? Kind of similar to the code that we had before. All right, does this work? I'm not sure if that works either. Type tuple TT is not a unit TT. Okay. Yes. Yes. Wait, why? Right. Well, let's okay. What we need to do is, in this case, we're going to have like the yeah, the empty AST is like the unit value. Wait, is like the unpacking of the empty tuple actually the thing? I thought that was not the case. We should just like include AST like this, and then do the comma, and the curly brackets are going to be added on like top. So this is like literally empty AST here. Otherwise, we include this one and follow up with a comma. And array to tuple is used over here. Unwrap, unnamed impl. So this is going to be surrounded with the curly brackets in the end. Right? Yeah, that's what I want, I think. Tell me this works. Unexpected end of file. Include AST, array to tuple. I'm not sure what is the priority on the include ASTs. I think that works. Did you forget? Did I forget the curly brackets? I don't think I did I? It says that I did though. But why? I think I know exactly why though. I know exactly why. Because this include AST is not include like expanded yet. We need to expand this thing. This is a bug in my compiler actually. Can I fix that? So we have the core syntax, and this has like the tuple impl, right? So what I'm doing is that I'm trying to collect the list, just like I'm trying to do here, trailing or leading rule name and binary rule name is this. So inside of this comma though, we have the inclusion of the AST, which you know. Oh no, I know exactly what we need. It's not include AST there. That's the problem. No. Everything's supposed to work. So we have array to tuple. This is a function that returns AST, and I'm trying to inject this AST into this AST. Include AST is when we want to compile, but since I'm constructing the AST here, I just need to like unquote this here with a dollar. Yes. And this also returns this thing, which is going to just a dollar here. Right? There we go. Now this includes the AST, and this is maybe is going to work now. Tuple. TT is not unit TT. Hold on. Right, because I still have like the empty one. Okay. Like over here, we have the empty, like if n is equal to 1, this over here before the first comma is going to be the empty unit, which is why this happens. I guess what I can do is, if n is equal to 1, then like it's a special case. Because like otherwise this returns this becomes not a trailing comma, it becomes like the preceding comma. But even if it was a trailing one, like this is still the empty AST, not like the empty thing, you know what I mean? Like it's a little weird. So n is equal 1 is also another special case, actually. If n is equal to 1, then we need to have the AST, which is literally just that at 0, right? Field unwrap unnamed is not there. Okay, so now it actually compiled, and we can do unwrap unnamed 2, and this is unwrap unnamed 1. Unwrap. Let's do unwrap single unnamed also. No, let's do unwrap unnamed 1. That's okay. So unwrap unnamed 1 is just returning the T, and this is going to. What's my plan for bootstrapping in the future when the compiler is completely written in itself? Give the previous version JS in the repo. Yeah, we can have like the transpile JavaScript in the repository, I guess. And then later when we are going to replace it with the C. Yeah. All right, we've done a little bit of the macro magic here. Nice. It doesn't type check. When doing this. Oh, because this one is 1, of course. This is not 2. This should be 1. AST is not a child. That is correct, right? So now, because left-hand side is supposed to be, because this children is children, right? But we need to say that left-hand side, AST, unwrap child AST, unwrap child value, AST, unwrap child value, inner unwrap child value, because the children of the ASTs are not necessarily ASTs, they can be groups instead. Right. So I want to unwrap child value is a self child into match self with, if it is value, it is value. If it is group, then we panic. Expected value got group. AST child is not group. Over here. Group underscore. Can you do this in Kast? Hold on. I need my stuff to type check. It's binary. Let's see. This is going to be, you know, what did I call it? I think I will use the same name. It's trailing or leading rule name. It's a little bit longer, but you know. This is going to be trailing or leading rule name. You're currently getting Jason to type check too. Let's see, TypeScript playground. Type foo is bar number. Type baz is foo bar. Currently I cannot do that, I think. Well, I mean, no, you kind of can, right? Let me see. Let's try to do it in the playground over here. So we want to have like foo is a type, which is like field int, right? So you want to figure out the type of foo field, right? This is obviously not here, right? Cast playground test. It's going to say that no impl of type test foo as module. I mean, I guess you have like implementing this as module, right? But it's not here, of course. Let's just say something like that. Right? It's going to say field foo is not there. That's correct. What you want is do this. I guess. What you want is do this. Let's see here. Field type. We want to have a function which takes the type and the field name, which is a string, and we want this to return a type, right? We want to write this function. The only, like, I cannot write a function like that, but I can write a macro like that. So it doesn't have to be a type then, right? It's going to be AST. Yeah. And field name is also AST, I guess. We can do it only with a macro, I think, currently. We want this to be eventually. Well, I mean, technically, I do have the type inspection APIs, so this needs to be in the standard library. Yeah, I know. I'm just saying that you can write this. Right now, like, we have the type of operator. That's what I'm saying, right? So you want to say, like, type of something like this. Let foo of type foo be equal to underscore, like this. The value doesn't matter here, right? But if you have the value of type foo, I guess you just do this. You have underscore of type foo, and you want to get the field of the instance of this type like this, right? And this is my type of, right? dbg print. Let's see. Does this work? There we go. It's an integer, right? If I change this to a string, then it's going to be a string. And then you can, like, create a macro that creates this for you, I guess, so that, like, you don't inline this manually. But yes, I agree. This we have the type inspection APIs. You should be able to just call a function at compile time to get the type of the field and stuff, right? It's in the reflection, right? We have this type info, which it was for tuple. You can have, like, this named. This is a singly linked list of string and type. So, like, technically you can actually write a function at compile time that also does the type info inspection. And then, like, if it's a tuple, then you can go over the named fields and find the correct field that you want. Right, that would be another way to implement this. But type of, I suppose, is, like, easier. All right, anyway. Type tuple. Do we still not type check here? I still not type check. Yeah, over here we say trailing or leading rule name is none. That's a long name, but it's okay. We can do that. And this takes the AST. Trailing, yes. All right, did you forget the things? Okay, I think this doesn't work. AST. I need to, like, figure out why that doesn't work, actually, too. This is because it's weird. That should work. With the pipe operator. Alright, now this is still the problem. AST binary. Oh, it's like this thing is still called binary. Wait, what? Yeah, binary rule name. There we go. It's even longer. Alright, now what? Now what? Now we have this. Yes, because this returns object, And this should just be return, right? Return object with the fields. Okay, I just need to like figure out the field. So now that we have the field, which is an AST, right? Now every field must use the field syntax. JSON here, right? We have the field syntax. Okay. 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 Boom, 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 boom. So we need to match field shape with, if it is the rule, root, children. If it is anything else, no. Dun, dun. This if field shape is rule, then we do something. We say if rule name is equal to field, then we do something, and we continue. Otherwise, I'm going to report the error here, right? This is at the field span. We say expected field got the rule name. Okay. And over here, if it actually is a field, then it means that... Okay, now for the field, we have the named... we have the name and we have the value. Let's say name is children. So get named name, right? Get name probably should return a reference, so I would like do this and then dereference that stuff. So we won't have name and we won't have value. And we also want this to be like AST unwrap child value, right? Like that. So I need in the tuple because I don't think I have done this yet. I don't have the getters. Get named t self tuple t name string. This should return optional reference to t. Which we just say or map get name in self named, right? Like this. Just need to import the tuple here. Well, get name returned an option, right? This must be present there. This must be present there. Which means that I want to do option unwrap or else. Unwrap or else something. I need to report the error. Well, I mean, we just say unwrap, right? Because we are assuming that the JSON syntax is done correctly there. So yeah, I just do unwrap here, actually. This is okay. This is okay. Totally fine. JSON T is not string or object or number, right? Because I called it not obj, I called it object. Correct. Okay. While transpiling, something happened. Transpiler. Hold on a second. There is a to-do in the transpiler, it seems. Line 1300. Over here. A quote AST. Okay. A quote AST. Because I... Okay. That makes sense. It's because I'm trying to transpile this function that I was writing somewhere in the tuple, right? I'm trying to transpile these functions. But these functions, they're only supposed to be present at compile time. But I'm still transpiling them because I'm transpiling everything in the tuple object. So what I want is I want to say over here CFG, and if target name is JavaScript, then I don't do anything. Panic. Comp time only. Well, I mean, yeah. We can just say the target name is interpreter. Then we do all of this stuff. Otherwise, comp time only. I do this here. And I do this here. Module is not defined. Module iter. Wait, is this also a miscompilation? This is in the AST iter list. Because over here I'm creating the module. I say iter. Module is not defined. Let's take a look. Right, I'm saying that module iter is this. Module. I am creating it. Wait a second. Why is it not defined? Like, if it's literally like in the previous line over here, right? I'm defining this. And it says that it's not defined in this line. I don't understand this. This looks like correct JavaScript, right? Totally normal JavaScript here. Wait. What is the line 21434? Oh, it's earlier inside of this function. To 1434 is this one. Wait a second. What is happening here? This is the line. Iter is equal to that. Yeah. This is the function. Why is it so difficult? Wait, am I compiling this multiple times? Like, this is over here. This looks correct. But then I have it further. Again. Over here for some reason. What is this? Unwrap unnamed one. Unwrap child value. Module. Module iter. This is the line that doesn't work. The reason it doesn't work, because for some reason I use a different ID. Wait a second. This is wrong. Why am I not saying this module? But I'm saying this module. This is miscompilation, I think. This is miscompilation. Let me take a look at the how we do expression module. Right? When we do expression module, we say module var, right? We generate a new name, module. We go over the bindings, module of binding. Oh, yes. Oh, hold on. Wait, what? No. Huh? Module var. Yeah, I'm adding to like these bindings, so for that to be their module variable. Right. So that when I'm transpiling this definition, the module is the same. But the problem is that I'm transpiling the definition twice. Why am I doing that? Because of something. Because of something. I'm transpiling the same definition twice. And then like we have this issue. Because the bindings are the same. Probably. Let rec. No. Okay, how else can I do that? Well, I mean, I can for now ignore the miscompilation and like rewrite this in a different way. Right? I can. I can just say that
Being nice is nice.
being nice is nice. Indeed. We can just do this. We can flatten this code and like recursively call this thing itself. So we just say iter list, but like these must be like now explicitly parsed as the extra arguments. Let's just call a recurse something something. Let's say a recurse is a function taking the AST, which is going to, I guess I can do it over here. Recurse AST is iterate list AST binary rule name trailing or leading rule name, and then we iterate using the consumer like that. Am I inside the house? Well, I'm not on the street currently, yes. I'm in front of my PC. I'm having a skill issue with unwindable blocks. It's like just the named block that you can return to. What's the issue? Cannot access value before initialization. Oh no. Oh no. We have another miscompilation. Shoot. Can I say AST iter list? Maybe. Can you define a function that unwinds outside of the unwindable block? Yes, you can. You can have the unwindable block gives you the name, and this is just a regular variable. You can pass that variable to another function and then unwinds to that. Yes. Okay. Error at JSON11 expected field got object. Line number 1, line number 3. I expect field here. Why? Did I expect field here though? Hold on a second. Hold on, JSON. It's because I am iterating list of the AST, but that's not what I want. I want to iterate over the child of the object, right? So I say that inner is children tuple unwrap unnamed one. I want underscore here actually. Underscore. I like that. Alright, so over here I'm named one AST unwrap child value. This is the inner, and this is what I'm supposed to iterate over here. Okay. I'm almost there. Is there anything specific you need this JSON dumping for right now? No. I'm just trying to see if my parser can parse JSON, right? That's all. Has named fields. Let's see here. Oh wait, no. It actually is not that, right? In the JSON syntax, the object has the fields, and this one has elements. I mean, I can have this being unnamed actually, and this is okay. Yeah, I'm just going to make this unnamed, and then it's going to work. Do you have to put the unwind function in the context? Yeah, you can do that too. Do you make a profiler yet? I do have a way. I have profiled multiple ways. I can profile like the target code using the like Node.js profiler or browser profiler, or I have the option to profile my interpreter. I could also image some instrumentation for profiling in the compiled JavaScript myself. Well, whatever. I did not like make profiler, but I have profiled my code. All right, hold on. Okay, object. Okay, object, which is empty though. It's empty because I have name. Okay, I have name, I have value. Okay. Okay, I have name, I have value. And then I also said value is from AST value, right? So this gives me the JSON. And now, why would the Kast parse need to parse JSON? It's just a test, yes. It's just a test. But also, I don't know, maybe we will have the way to parse. Like, I can see, like, I don't see much value in this, but I could see the syntax like this. You say like JSON, and over here you have like the JSON object, you know, field value, right? And this gets converted into the JavaScript value, which we can use in the language for some reason, you know, to do the inline JSON, similarly to how, you know, in Rust JSON macro. I guess third JSON has the macro, right? Yeah, there we go. Like, so in Rust, using third JSON, you can have this macro which creates the JSON value, right? Something similar to that, but this is not like I mean, it's basically also a macro, I guess, right? It's very similar. It's just we have the syntax highlighting for it. I mean, there's not much to highlight in the JSON, but anyway. You know what I mean, right? It's a way to embed JSON in the language. The zest. Support for interactivity and liveness of the systems like Emacs without giving up on civilized luxuries like static typing, early bindings, jump to definition, supports kind of interactions, code and test, 1 plus 1, 2, 1 plus foom, cannot call zest built-in add with these args. The strict dialect doesn't currently have a way to print values from wasms. Like what? Rationale. I don't understand the interactivity and liveness of the system. I mean, interactivity what means that we want to have the interpreter or what? I don't understand like Emacs because I don't use Emacs. Support the kinds of interactions, exploring the research prototypes, but I don't know these prototypes. He was working on adding more floating point support recently. It was really easy to get a hang of the code base. Wishes, malleable, leave reloading as seamless as possible. Yeah, I have not like thought about like the hot reloading of the code yet. I do have REPL, eval, introspection. We do have that. Query code gen. Oh, so Julia Code Native has done. Wait, okay, so like. So that is prints the native assembly instructions generated for running the method, matching the given generic function signatures. This gives you like the assembly, but I'm planning to give you the not the assembly, but like the high level internet representation. But yeah, basically we can query the things. Sure. Tools as libraries. Code-based rather than image-based. The code running now is the code that you loaded. Nobody can sneak in and change it at runtime. No side effect at load time. No life before main. Okay, charge early. Do 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 do. Pum. I mean, yeah. Mutable XOR shared. Does it mean that we have a borrow checker here too? They have a borrow checker. Interpreted and compiled. I don't know. Seems like a lot of the ideas are the same. Like one of the things that I have not thought much about is just delivery loading. Everything else seems like maybe similarly done. Depends on like the details. It says it's both dynamically and statically typed. Type check each function after specialization. Which is achieved by executing code at type check in time like zig tetra. Yes. Yes, we do have like this, but it's not like, what does it mean after specialization? I do achieve the expressibility of the static type system by executing code at type check in time, yes. There is no separate type language. Yes. Downside is that we cannot verify that a given function will type check successfully for every possible specialization. But I do that. But it's like as like I was just trying earlier, right? There is a like an issue where languages like Zig can compile certain code where I need to have a macro instead. Because if you type check earlier, then how do you ensure like the thing is the issue? It's a different trade-off, I guess, but I think I can like improve this without sacrificing the early type checks. Something. Scattered. Thoughts? I don't know. One of the language's biggest design goals have uniform representation of data across every part of the language, derives a lot of the design decisions. What does it mean, though? Uniform representations of data. Does it mean that the lists are represented the same as objects? Syntactically, not as a universal layout. What does that mean? I mean, maybe I have the same thing, right? Like, for example, right? For example, let me give you an example. An example. Over here, I was writing this, right? What is T here? T is type, right? And this is a generic, but generic is basically like a function. So the types are regular values. They just have the type. This would be the more explicit way of writing this, right? So this is the argument to the generic, similar to how this is the argument to the function, right? And this is just an expression which resolves to, I mean, this in this case is a pattern, but like this over here is a type expression, right? So this T is a variable of type, and then we use it over here in the type position, and like I don't know, I don't know, like what it like anyway, like we can say true here, right? So like syntactically we can use this value here. We're just going to have the error here, which is going to say that true cannot be a type, right? But syntactically, I allow any value to be here. Is that the same? Like for any type variable v of type d, deserialize, serialize v is v. But like that's not about the syntax though, right? This is about serialization. Yeah, so like what do you mean exactly? Is there, like, can you link to a specific section in the docs maybe? Or you mean like it's represented? So yeah, like if you serialize and then deserialize, you get the same thing back. Yeah, like the shape of data. It's because it's about the serialization thing, right? Like it's about the serialization shape of data. Let's see. When you write this Rust code, I have to think the code that I write to create and change the data, the in-memory representation that I use to think about the code, how the code executes, the printed representation that appears in my logs. Even though the data model is the same in all three cases, I have to deal with three totally different notations for describing the data. The code that I write to create and change the data, the in-memory representation, and the printed representation. Okay. So you want to like represent the objects in code same as they are in like data in when they are printed. Yes, I agree with that. That's like one of the issues of why I don't like but you don't always want to do that actually, right? Because hash map contains like these implementation details. How do you represent the hash map in Zest then? It's because you have a built-in object which is a map, which is a hash map. Only then you can do that, but that you're restricted to a single implementation of the hash map. If you want to do a custom one, then the visual representation, you want that to be different from the actual data representation. No. That's a lot of text here. I'll keep this tab open. Yeah, like having built-in maps like fixes this issue, but like you still want to be able to write a custom map sometimes, right? Right? And then you want the visual when you print it to the terminal, you want it to still look like a regular map. No? Because otherwise you are dumping the internals, which is what I'm doing right now. Like, for example, if I say, I don't know, let's say this, let map is, let's say use std collections ord map. Like, this is not the standard thing. Map is ord map new, right? And then I say map ord map add, you know, key and value, right? And then if I look at the map, this is the representation, right? Right now I'm actually dumping the internal representation. So this is a node which has like left and right subtrees because it's the map represented as a tree. And it also stores the compare function inside of this. But that's not what I want to see, right? When I'm printing the map to the screen. I want to print something else. I could make these two representations the same if the ord map was the built-in type, But I don't know, like sometimes you want the custom things with a different visual representation from the actual representation in memory. So I don't know. I'll read this off stream, see what I think about it. Has my opinion of a camel changed since I switched back to it from Rust? What was my opinion before I switched back? I think it did not change, but who knows? I don't remember my opinions. The opinion is that OCaml is compiling faster, but Rust is a better language. That's the opinion. This has structs as a subset of objects with a fixed set of keys. Yeah, it makes sense. It's like, yeah, it does make sense to do it like that, I suppose. If you have the objects with like any amount of keys, but what if the keys are not strings? Does that support that? Can I have a string being like a complex object? The key being a complex object? We have ref is not defined. What? Wait, what? What was I doing before we were distracted by this? What was I doing? I have not committed anything. The ref is not defined. Okay, we have some miscompilation here. It seems this ref, this is children. Shape, data, root, children. This is rule, this is children. And if name equals to this, field. Okay, so this is the code. This is this code. There is something wrong here. There is something wrong here. This reference specifically, it's not found. Oh, this is the first. First? Wait, what? I don't have firsts anywhere. First. First? First? Is this the pattern matching? Unmatched value. If true, match result is this. Yeah. This is the two pattern match branches. Which is this. The trade-off Zest is good for is that the built-in types can be fast enough because it synergizes well with transparency, generalization, digitalization, and hot reloading. It's not trying to be a systems language, though it's trying to be faster than most constructed languages. Okay, yeah. Maybe. Yeah, hot reloading is an interesting topic. I have not thought about it much. Alright, I have some issue with my transpiler currently, I think. Okay, you know what we can do? We can try to run this code with the interpreter. Self cast args. Let's do this. Run this through the interpreter. To do multiple values for key. What? Of course. No. I'm hitting more issues in the language. The interpreter also doesn't work. That's the different issue, though. Custom types that aren't built on top of built-in types don't have an obvious way of serializing to serializing them when one of the custom types is just a struct that's not much of a limitation. Yeah. One of the things that I've feel like is happening with the languages that have the code reloading is that you can reload and then the type checking is now like the code is no longer type checked properly is the issue, because you rely on like this serialized representation which is like uniform and everything, but like let's say you added a field to the type and you still have the old struct live in your program, right? Now you have new code which uses this new field, but the old value does not have this. So you're going to have some form of migration from the old version to the new version. Does Zest have that? Because in languages like Java, you would have just a runtime error. As far as I understand, I haven't used hot reloading too much, but I did get some of these errors, I think. Ref 19 is not defined. It's defined over here. Two 741. And the error is at 26547. Yeah, indeed. The type check in semantics are specified in terms of runtime type tags. The static type checking is just static analysis. Yes. Of where a runtime type error is guaranteed to happen. So what happens then, right? When you try to use the old type in place of the new type, you will have the runtime error, right? Because the type tag is different or something. I think the migration thing is present in the languages like Erlang. So in Erlang you can also hot reload, and then you can specify how your data is supposed to be modified if when you leave reload, basically, from the old to the new version, I think. But I have not used the Erlang, so I have the miscompilation. What do I do about this? This reference is created over here, but then I use that reference in some other place for some reason. Oh no. All was good, and then it's nothing works anymore. dbg print rule. So I'm not getting here. dbg print field shape. Erlang support for migration is a pretty bare bones. You still have to do a lot of it yourself. Makes sense though. It's hard to do automatically migrate in the general case. Yeah. Okay, we have the field rule. I'm not getting here, which means that this code is being this code over here is being not type checked. I'm wondering if the reason it's not being like generated correctly is because I have the inner pattern here. So what if I say this? We have root, and then I say that children is root, you know? And then I'm not going to have the miscompilation. Nope. It's possible to define an impl type as module method on the impl module is defined. Reference to impl type as module before it's defined. Maybe you should try it. There are maybe just some issues in the language. It's supposed to be working, right? It's not working? Okay. So, okay. It's not working, Nigel. Yeah, because I'm not waiting for it to be defined. Yeah. Makes sense, makes sense. It should be fixed, though. Eventually. dbg print root. Am I getting at least, like, over here? I am getting there. Oh, wait. So this is not being compiled correctly. Why is that? Is it because of the ... here? What if I just say children? Because the rest is just empty anyway in this type. Nope. Can I say children is root children? Because that's the same thing. I mean, maybe I'm also like dbg print 1, dbg print 2. Like, is this the issue? Or do we get somewhere else now? This is the issue. Why is this the issue? What is root? AST group. This is just a regular type with the children field, right? Or is it because like this over here has successfully compiled, right? Even although this and this is kind of like the same thing. I guess the difference is because this over here is a match and this one is an is. But it's supposed to be like the same thing. What's the issue? The issue is the root? dbg print root. No, I think like root works. Right? Yeah, it did print something. Okay, let's take a look at the generated code then. A little bit. So I have this line, this reference is not defined. I have children, which is this. This reference is this reference. Oh, wait, is it again because I'm compiling the same code multiple times? It seems like a very similar issue. This is dbg print children, this is print 1. But what is in the other place? In the other place, what is this code then? Ah, and this is where I am seeing if it matches, right? If it does match, then I'm generating the code to perform the pattern match. But before I pattern match, right? Before I pattern match, what was the line? 6.5. Wait, this is actually a lot earlier. This is a lot earlier. This is a lot earlier. I'm compiling this function twice, am I not? Let's see. Like, what is this function, for example? Something that checks for the rule. Yeah. How to make things work. How to make things work. Let's try to match here. Match field shape with rule. This const from ASD. Wait a second. I think I know from ASD. I think I know. The way I fixed it in the other way is because this over here from ASD makes me compile this function again, because this is like capturing this directly. But if I say instead JSON from ASD, this is going to use the only single compilation thing. I think I understand this. I need to make a minimal reproduction. This doesn't work. Hold on. From ASD. Like this over here is also going to be JSON from ASD. Holy shit, is finally compiling. Your JSON? Who is going to get the work in JSON first, though? I am also compiling. It's just that I am also miscompiling. All right. Successfully parsed null. Nice. I have only parsed the single string so far, but I think the null will be parsed too. Okay, let's do this. Let's extract this into a function maybe. Parse object. So this is going to just have the children, which is a tuple of AST child. Then this will return the JSON value, I think. So let's extract this over here. I'm going to return parse object children. Let's see if extracting it to a function somehow fixes something. The study of Swift type checking is pretty interesting. Of the Swift. That's a lot of text. Hold on, I want to have something working. I do like distractions, but couldn't find syntax rule in scope. Syntax rule. Like, I'm so close to actually have the successful JSON parser. Cannot access value before initialization, but we keep hitting all of the things, all of the bugs in my compiler. You know? So, like, I'm trying to figure out if I can work around it. Can't access value before initialization. This is parse object. Oh, I'm creating this before initialization. Parse object, literally. This function is somehow special. What if I don't do the fields here, though? What if we do this? That's the same as the code that we had before. This is going to work, right? It was working when it was inlined here, though. This is going to be parse list. Are all children. Parse array. Array. Parse array. Cannot access value before initialization. So this is just when I'm creating this. This is the object, which is supposed to be, you know, this is like the module JSON, right? So we have the rule set, the parse error there, parse object, parse array, all of these things, right? But then it says value 396 is this one. Oh, wait, this one is the parse, right? So this value is defined later. It's literally defined after. What? How is that possible, though? Or is it because it is recursive? No, 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 no. Well, I mean, yes. In order to compile this module, right, what we're trying to do is we're trying to like transpile all of the fields here. But these fields, they are reporting the JSON, they're capturing the JSON itself, which means that I need to do that first. And when we have the recursive thing like that, something happens. So I cannot create the recursive modules. I see. Which is why, like, when I'm compiling the modules at which created at runtime, I do it differently. Let's not use the JSON dot then. Let's not use the JSON dot, I think, and it's going to work then. So, like, if I actually just use from AST, I think it's in the types. They should be fine. Yes, like over here. I don't want to do that. Yes, this actually fixes things. Okay. So okay. I should make a test for this. Real quick, playground test. You know, we have like a foo, which is a module, which has a foo, which is just calling foo. You know, just the recursive function like this with infinite recursion. But it's just not going to compile here because I want to say like foo like this, right? And then let's just say cast target JS playground test. This is going to cannot find foo in scope. Yeah, because like this also all happens inside of a module, right? So that I can access that, right? No, this actually works. Maximum call stack exceeded because this is a runtime module, right? Yeah, we need to say const outer module. Or I guess what we do is like we use this module entirely. Use dot star. That's like what we do in our code there. There we go. No, wait, what? No, maximum call stack size exceeded. This is still compiling. What if I call it a different function? Although I don't think it matters. That works. It works. Why is nothing breaking? But when I try to do something useful, then it breaks. Okay, let's do one by one. We're doing the parse object here. This works. For field in this, do that. Let's just see if I can iterate over the fields. I can. Now if I open this code, then it's not going to work. Yes. If I comment the insides of this, then it is going to work. dbg print root. It's the same code, right? So the fact that I moved it to a function didn't help anything. Wait, this works now. Hold on. Root children, this works. This works. Okay. What doesn't work then? If rule name is field. Is it the rule name that's breaking? It's not. Okay. So I actually have gotten further. Okay. Okay. Let's see, name. This works. Let's see, value. This works. Value from AST. Like, I guess this is what breaks it because I'm recursively calling it, right? If I don't do this, then it's fine. So the issue is the recursion. And I believe the reason is because I am calling it and it is being transpiled twice. I believe that is the reason for the bug. But if I say JSON from AST, and it says cannot access value because it's like trying to convert this object itself. Okay, maybe I just change the compilation of this. So there's like two bugs. There's two bugs. And I cannot like recreate this for some reason. Can I compiled JavaScript? Let's see. Who is this value? And this value is like done before because this is based on that, right? And this is this, which is based on F, which is over here, right? How does this happen? And what happens when I do it compiling twice, right, is another question. It's similar to the module, like in these bindings and everything. Oh, maybe it's because... I don't know. Yeah, in that other place, I had the miscompilation of the module in the function that was transpiled twice. Because this is context only for this transpilation. Module of binding. Like, I'm mutating the context instead of creating the new context, I think. I have the mutable part of the context, but this is incorrect. The module of binding. This is the only, I think. But that's like the different problem, once again. That's a different problem. What if I have the function? So these are creating the references or something. We have captured places, captured values. A ref vars. Yeah, maybe this? Hold on, ref vars. This is based on string map. What is ref vars? Place of var, which is this name. Yes. Because the name is the same. Because the name of the variable is based on the ID. It is complicated. This is complicated. Mm -hmm. So this doesn't matter here, really. Okay, I want to like figure out why is this compiled twice, right? Because we have the parse object. This parse object is only called in the from AST. From AST is only called over here and over there, from inside the parse object and from here. So why would this be compiled twice is the question. It shouldn't. Let's start with the simpler one. Maybe like this over here is the nested list and stuff, right? This is over here. This is a 4. So this is the body of the loop kind of thing. Let's try to do the list instead. The array. The array is similar. We're going to go over the children. Elements is going to be array list new. The inner is like this thing. So we have the over the comma, we iterate. But then I don't have the fields. I just say that, yeah, I should have started with the list. Array elements. Just say array list push back elements. The from AST. From AST element. Right? This should work. Let's have the hello world. That's the same thing. This is in a different place. It's almost like Pattern match non-exhaustive. Add JSON token 93, line 93. Line 93 is this, right? Okay. Yes. So this was the pattern match. Then we have the match result. And then we break the outer pattern match. Now we are, yeah, and this over here is me trying to pattern match this next thing, this rule. It says this is me trying to like create the references in a fancy way. Yes, I know that. Okay, you know what? We're going to. I know how to do this though. We have these ref vars. Okay. I know exactly what to do. When we have place of var, it's a place with ref var. Like this over here, I want this to be disabled. Host place here is a transpiled place. When ref vars enabled. Let's do that. Let's do have a, so we have like the async function miscompilations. We also have like this, use numbers instead of symbols. Let's say also ref vars enabled is going to be true. And then in the compiler CLI, we can do something similar. Disable ref vars. JavaScript ref vars value. Ref vars enabled is this. Let's do this parse JSON. Unexpected argparse JSON is parse dash JSON. This is going to be the same error as before. Wait, what? Unhandled rejection? Wait, that's a different error. That's a different error. That's another bug. Because I was throwing instead of an async function without a catch block. The regular stuff works though, right? No, wait, this also doesn't work. This is something different. It's because of where I'm doing this, maybe? Because of the... I am having the object. What's inside the object, though? Okay, you know what? Let's just commit this and try to do that. Kast. JS ref vars false. Let's load it here. Right, like I can self-cast parse. It tests hello, right? I can still parse a hello world, right? It's for some reason doesn't work when I do it from the other place. Yes. Let's update Kast here. Alright, I'm going to try for a little bit longer, and if it doesn't work, then we have a bunch of bugs to fix. So, I don't want to do that right now. I'm going to go rest instead then. Is my internet slow? It was downloading the things very slowly or something. Timeout was reached. Okay, so this works. Parse JSON still will not work, but if I go to the flake, and I also have a, so we have async always, this is false. We also say JS ref vars false. And then maybe if I do that, it actually did work. List is not a valid JSON, right? Wait, this actually compiled. Okay, yeah, so I have like the miscompilation on, like, because we were trying to do optimizations. Every optimization, I guess except for numbers instead of symbols, this is just so that I can see the debug output easier. But these two optimizations are resulting in miscompilations currently. Okay. Okay, we can just disable the optimizations, is okay. That's okay. JSON list. Right. I want to call this not list but array. And then it's going to work. Right? Right? Okay. Yeah, we have array of hello and world. Nice. Now we are going to have the object here with key 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? The object is still empty though. 6, 7. Sure. So over here, parse array, parse object is not finished. Because over here we have the value and we have the name. The name is still the AST, but I want a specific AST, right? We say that name is, let's say, AST to name, name. Yeah. That makes sense. AST to name is taking AST and returns string. So this is going to match AST shape. If it is, I mean, it must be a token. In any case, I guess. If it's anything else, then let's just do return here. If AST shape is token, and we do something, I'm going to otherwise report the error and unwind. AST span. Expected field name got expected field name at span print AST span. I mean, expected field name. That's it. That's okay. That's good enough. All right. So if it's a token, then we say that token shape is either a string with the content. Then we just return contents. It also could be identifier with the name. This is not like the JSON. This is JSON 5, I guess, right? If we want to have the raw identifiers there, then we also return name. Otherwise, we just don't do anything. Could not find returnable in scope. Not return, with return. Unit is not string. Semicolon needs to be deleted. All right. Now that I have the name and I have the value, we're going to say fields ord map add name value. That's all that I need to do, right? Hello, Athano. How am I doing? I'm doing okay. I am like catching all the bugs in the language. But I am parsing JSON with the parser for reasons, because why not, I guess. JSON, yes. If rule name is equal to null, then return null. There we go. We can also have like the null, right? Right. Over here, we can say syntax null. This is 1 billion priority. This is literally a single keyword null. Here you have extraction, KDL. I know what KDL is, yeah. You want to talk about the different formats and which one is better? I have a Kast object notation. by just evaluating Kast code. So I don't need any of that. But in order to like work with one of the next goals that I want to do, right? I have the parser here. The next part, I'm going to start with the language server immediately before starting the compiler and interpreter, because I want to have the syntax highlighting. It's going to work through the LSP semantic tokens. So the LSP is going to just do the parsing and reporting the things, and also we're going to have the formatter done in the same way. So I want to start with the LSP immediately, which requires doing the JSON RPC. So I need JSON. All right, let's also print the JSONs a little bit better. Let's do print. So self is JSON. We are printing JSON. Let's see, we are going to match self. If we want to have null, let's see. Here's all of the JSON things. Let's see, number float. Number value. In this case, we are going to say ANSI with mode. So the numbers I do italic, I guess. And over here we just say output write to string value. Okay. The string we are going to print with green. We're going to write escape string value, which means that I need to import the common or something. Strings are green, numbers are italic. Object fields, this is going to be output increase indentation, output decrease indentation, output is current output, output write, and opening curly bracket, a closing curly bracket, and then we do for index and field in fields ord map iterate std iter enumerate if I is not equal to 0. Wait, how do you? Yeah. Let's do this. We're going to increase indentation. Let's say if I is equal to 0, if it's the first field, then I'm going to increase indentation. Because I don't want for the empty ones to be indented, I suppose. But if it is empty, then I'm going to write the space in between, I suppose, right? Otherwise, we decrease indentation. And things. If it's not the first field, then I'm going to write the... I'm going to also write the /n always before the field, right? Or no? Yeah. So I don't do else, actually. I don't have the size of the map is the issue. I could implement it real quick, though, but I don't have it right now. I guess before /n, I'd say that if I is not equal to 0, then I'm going to write the comma, right? Then we write the /n. Then we increase indentation on the first one. Just say it's empty, it's false always. Then we are going to write the field key. Can I just print string field key, so that we are just going to use this color? And then we are going to output write a colon, and then we're going to print field value. Like that. If I have an array, then we say for... That's kind of similar. We just say not order map iter, but array list iter. And then I just don't have the this is element, which I just print like that. And then we don't use the curly, we use the square brackets. If I have boolean, magenta to string value. If we have null, then we do add a magenta null. So we don't debug print JSON, we should say JSON print JSON. Let's see if I did the compilation error somewhere. Oh, it's not commons, it's common. And there is this error over here somewhere. Can't find a value here because this is S, escape string S. Alright, this is going to work, right? Just 200 lines to parse the JSON. Is that a lot? I don't know. Row inference failure. Oh no, hold on. Over here, row print. I mean, it's supposed to be like JSON T, right? And JSON. Oh, because this is a result, right? Right. We're going to, I guess, match JSON parse with, right? If it is okay JSON, then we are going to print it. Otherwise, if it's error. For error, we have span and message. Is that it? It's not span and message, is it? It's message and position. Okay. It's position instead of span. Span would be better. Let's just panic to do. All right, beautiful. We have a list with hello and then an object which just stops. Why does this stop? Hello? Where's the rest of my output? I have a list, right? I mean, I'm also starting an object. I'm iterating over the fields. Iterate, enumerate. Am I like dbg print field? Is this also miscompilation? It might be. Like I'm not even getting further. Yeah. Okay, where am I getting then? Where am I getting then? Output right. dbg print s. Use the Kast debugger. Yeah, which is called print something to the terminal. That's the Kast debugger. Wait, I am printing the closing bracket and I am printing the closing list thing too. Okay, I understand now. It's because I never print the new line, right? Because like I need to flush the output and it's only been flushed when I print a new line. So after I'm printing the JSON, I need to say write /n. There you go. That makes sense. It's also like, and the reason this is required is because I forgot to have something. If the program exits, it should also auto flash. No. That's not how it's done. I cannot detect the exit of the program. It's like it's the manual buffering for the escape codes and stuff, and for the indentation, you know. So like the only way to for it to be done automatically is when I implement the drop semantics, right? Where the RAI basically, right? Where something goes out of scope, then we like clean up. But I don't have it yet. But if we had that, then yes, I could do it automatically too. Yeah, it's my own buffering because like this is the output which can like do the indentation and stuff. Yeah, it's not about the thing. Yeah. So yeah, also you see here then we do this, which is wrong. JSON, right? Because I'm not printing the new lines. Because if it's not empty, I should also print the new line over here. Here and here. There you go. This is going to work first try. Look at this. Look at this. We have hello, and then we have key 6-7. Right? Let's try the more complicated JSON. Let's try this one. So this is the JSON that I actually get from JSON cannot be true. Wait, what, really? Hold on. Yes, it cannot be true. True is supposed to also be a keyword, I suppose. Null, true, and false. Right. This JSON that I gave it is the JSON that the actual VS Code is sending to me when initializing the LSP. So that's what we will actually have to parse anyway. Let's see. If we have true, then we return boolean true. If we have false, then we return boolean false. Okay, look at that. Client info, VS Code version 1050. Process ID, root path, workspace folders. All right. Okay, the JSON has been parsed successfully. I'm not sure if I'm parsing the Kast code correctly yet. There might be like a bug somewhere for some reason. Yeah, there's probably a bug somewhere. I also don't parse the syntax extensions yet. So yeah, there is still a couple things to do. But the Kast parser is general enough so that we can parse JSON with it. Right. Nice. Maybe like in the test. Parse syntax rules. I can also like try to parse all of the Kast code. So this is not going to work for sure. Right? Parse. But I can do self-cast parse JSON. Can you parse JSON 1 E400 into infinity like JavaScript? Yeah, I do not. It's not actually the JSON parser because it's using the Kast lexer. So because Kast does not lex the these exponential literals, so I will not do that. I can change the lexer, combine that with the parser, and then we'll like actually be able to parse the JSON. But Nigel is working on the actual JSON parser. This is more like a test. So let's run the tests. So we are already making sure that I can tokenize all the sources, the entire source of this project. That's a lot of output. No such file or directory. Yeah, it's like it tests syntax Kast, tests syntax. Can I just say Kast test syntax star ks? There you go. I can do that, right? Does this mean that like lexing the entire thing like took 10 seconds here, or is it just because of a huge amount of output? Probably just because of the output, right? So yeah, over here, testcast JSON KS. Yeah, this is not parsed because it doesn't work. The syntax extensions, but that's okay. That's okay. We are going to comment this for now. Here. Parse JSON. Is that all? I mean, you know what? Let's actually copy this test. Because why not? Copy projects, cast lang cast LSP. So I was doing the LSP stress test, which is why I have this JSON, right? Tests LSP init JSON. Just file. LSP init JSON. Right? Okay. All right. We have something working. I want to go rest, so we're going to end it here. Oh shit, I should actually, I wanted to like look at some of these tabs that I had open. I don't want to close that. I'm just used to closing my tabs all the time. All right. Let's go to Loomer, who's making a bash-like scripting language. Nope, we are not going to go there. They just stopped the stream, lol. Okay. Anyone doing anything cool? Misaka is writing some Rust, it seems. Let's go there. All right. Thank you guys for watching. See you next time. Bye.
Our index is greater than the